Perfect. Okay, shall we move on then on to Maria? So Maria Dermiki is a pleasure for me to present her because we are both based in Ireland and we share some common institutions where we worked together in the UK. So it is a small world, and she works at the Atlantic Technological University. So she's based in Sligo, in the West Coast, and her teaching and her research focuses on sustainable food production. And recently she has developed a massive online open course with the Food Cloud, and that was to enable food supply chain stakeholders to better manage surplus food. So thanks, Maria, and feel free to share your presentation.
Thank you very much, Simona, for the introduction. I hope you can hear me all.
Yes.
And thank you very much for giving me the opportunity to be here today. And I'm actually going to present the work of my PhD student, Shelley Fox. So it is also great to talk after Joy, and I want to thank you, Joy, for I don't know if you can see which one you see. Do you see my
we see side-by-side presenter, so we see two of your slides right now.
Okay, so it shouldn't be this one, but I'm just going to change that. Apologies for that. Hide presenter view. So you should be able to see that now. That's great.
All set. Thank you.
So, so it is great to talk after Joy because Joy has done an amazing introduction describing some stats in Ireland, and I'm just going to add to the stats that Joy has just presented. So what I'm going to talk about today is actually an overview of the work that Shelley has done in relation to upcycled foods. So in Ireland, we have, like, most of food losses and waste happen at manufacturing and processing. And what we have seen is that 67% of food waste and losses generated at primary processing, although it is a small amount, this comes from horticulture. And just to note that fruit and vegetables, although they are a small proportion of the food that we consume overall, they generate a considerable volume of food waste and losses across the supply chain. So these are some stats that our colleagues from Ireland have measured, but as Simona has said, it's really difficult to be precise. So looking at the food waste hierarchy, and I saw yesterday that the EPA in US is using a different format, but the EPA in Ireland, we're still using the food waste hierarchy as you see it here. So of course, the most favorable option in terms of food waste management is to prevent them from forming. But the next best option is the reuse. And looking at the reuse, we are working on the new product development using surplus or substandard food. So this looking at the whole food supply chain, and again, it was discussed yesterday, the different types of food losses and waste that we have. So looking at food losses that happen in the beginning of the supply chain and moving on to food waste that happen towards the end. We also have the surplus food, that it is food that it is overproduced along the supply chain. So when we're talking about upcycling, is using this material, characterize it, making sure that it is safe, process it further, and develop new products that then close the circle. So these products are being reintroduced at consumer level. And then we're talking about circular eating as well as upcycling. So there are a lot of opportunities, as the research has shown, and the speakers yesterday and Joy as well mentioned earlier. So there are economic benefits that come from new food products, and of course, reduction of food waste and losses is one of the most important advantages of upcycled foods. But there are quite a lot of challenges there, and one of the challenges that we face is the ability to capture this material before they become waste. So capture this material as long as it is still safe, and also having traceability issues there, where the materials come, because this is a requirement of the general food law. And this brings me also to the review that Simona and her group have done on the regulations related to upcycled foods. And of course, the work that our colleagues who are here have done on the consumer acceptability, and how easy it is for the consumers to accept these products. And there are a lot of factors that affect the consumer acceptability, as research has shown, and also our research is in agreement with previous research. So there are consumer-related factors, such as socio-demographic characteristics of the participants, food habits, food neophobia and food technology neophobia, the income of the consumers, the educational background. But when we're looking at the food products, the price and the affordability, and again, thank you, Joy, for mentioning like the concerns that consumers have in terms of the price of these products. Safety is another issue. The environmental impact, and Amanda, I would love to see the life cycle assessment on upcycling. That would be very useful also as a proof for the consumers. The nutritional value, and of course the sensory attributes of the food products. So Shelley's PhD tried to find ways to reduce food waste and losses that come from fruit and vegetable processing through the development of upcycled food products. And like the approach that Shelley had was to explore a whole food supply chain approach. So looking at the different stakeholders across the supply chain, she did a mixed method study where she interviewed, she actually had surveys and interviewed people, stakeholders across the fruit and vegetable supply chain. And this gave us an overview of the current management practices and the extent of revalorization. I must also highlight that this gave us also an idea, as I will be showing you in the next slides, of the materials that are being lost and wasted, and also ideas for some products to start the research with. But what I'm going to present you today is the work that we have done in terms of consumers. And I'm going to show you 4 different studies where we used 4 different ways of collecting data. So I will start with the first study that Shelley did, which was a qualitative study. And this included interviews of participants of consumers in Ireland. And the advantage of doing these interviews online was that we could capture people from different parts of Ireland, and we have different, following different diets, different educational background, different age groups. And I'm going to focus, Shelley has published a paper on this work, but I'm going to focus on the work on circular eating or upcycling. So we asked the participants at the time, this study, just to note, took place in 2021, 2022. So we asked participants at the time if they had heard the term circular eating. And of course, the majority had not heard this term. But when we explained what we meant, and specifically focusing on peels and trimmings or other byproducts usually formed during processing of fruit and vegetables, and whether they would be happy to see these used as ingredients in food products, the majority said yes, they would like to see them, like they would be willing to consume these products, but of course, there were some concerns in terms of food safety and quality. Sensory appeal was important, and they needed transparency from the food industry. So I would like to show you now the work that we did with a number of other groups in Europe, where we tried through surveys now to explore consumers' views towards upcycled foods. So I'm going to show you two studies, one study where we compared Irish and French students, and another one where we compared Irish and Greek consumers. So the first study was a small study, it was a pilot study, and as I mentioned, it included Irish and French students, and we showed pictures this time. We showed pictures of food products, 2 savory and 2 sweet products. Like some were considered healthy and some not so healthy. So you see we have a soup, ice cream, vegetable crisps, and a vegetable juice. And we were asking the participants to tell us how much, how willing they were to consume these foods. And then we were giving them information that these foods were made from fruit and vegetable peels and trimmings generated during food processing, and how willing would they be to consume these products again. So what we had found, regardless of where our participants came from, so just looking at the pool data, but also looking at the French and the Irish students, we could see that in all cases, after we provided information, the willingness to consume these products reduced. We also found differences in which products were the participants were more willing to consume. So we found differences between the French and the Irish participants. And these differences could also be due to actual differences in the food habits, in the neophobia or neophilia, the food choice motives, or even the consumption of the daily consumption of fruit and vegetables. So we we repeated this study. This time, like this study was repeated actually in 2025. So this is a recent one, and we're hoping to publish this information. So we repeated this study with Irish and Greek participants this time, with a larger population group. And we offered these, we showed pictures of these 4 products. Again, as I mentioned, it was a survey. So again, we were showing pictures. The protocol was similar. But in this case, these food products were developed after having input from the fruit and the people working in the fruit and vegetable supply chain. So they were real products that we developed in the lab, as I said, using ingredients and getting ideas from the industry stakeholders. And what we found, again, we found that when we provided the participants with information on the origin of the ingredients, their willingness to consume these products was significantly lower. And that was very striking for the Greek participants. And when we went deeper into the data, we found that, yes, there were differences as well in their perceived income. There were differences in the sustainability awareness. There were differences in neophobia, neophilia. So all these characteristics of the participants that our colleagues have found in their studies were confirmed in this study as well. But the disappointing thing was that people would not be willing to consume these materials. And we were very careful not to use the term waste. We were using byproducts. But yeah, again, they were not overall. We found that sorry, I don't know if you see this one as well, but I'm trying not to show the picture. So we found that the product type was important, and again, as I mentioned, the socio-demographic characteristics, but it was disappointing to see that the provision of information led to reduction of willingness to consume. So the next set of studies that I'm going to show you actually included testing of some of the products that you saw in the survey. So we did, we brought people in the lab who tasted the soups and the muffins. So I will be showing you, first of all, I will be starting with the soups that you see here. So we had a vegetable soup that you see that was our control, a sample that was prepared by peeling the vegetables, removing the stalks from the carrots, and then we had a soup that we call it a waste soup, but this soup included everything that was still edible, but under different circumstances would go to waste. And the combined soup contained almost the whole vegetable and the carrots with the stalks. So we had these 3 different samples, and we asked the participants to score their liking on a 9-point scale, and also to score liking of the different attributes. As you can see from the pictures, these soups differed in their appearance, and indeed that was also revealed from the measurements that we did, and also they differed in their viscosity. So the combined soup was thicker compared to the other 2. And that was also shown in a way on the overall liking results, where participants preferred the control soup. They liked mostly the control soup, and they also liked its appearance. And when we were asking them to tell us why, you could see that they were they didn't, although the flavor was okay or the taste was okay, the color, which is the first thing that they would see, was not something that they would expect. We also found that the liking of the soup, as we call it, the waste one, was correlated with the food choice motives of the participants who considered very important the food that it is produced in an environmental friendly way, or the food the local food or regional food. The interesting thing that we found with this study was that when we asked them after they had tasted the samples, we asked them, knowing that the peels and trimmings were used to produce these products, if they would change their scores. And most of them didn't want to change the scores, and only actually 1. You can see that we had a few who would like to increase their score, but we only had 1 who said that they would decrease their score for the combined sample. So as you could see with the soups, the product development was like the actual products that we developed that contained the upcycled ingredients were very different from the control. So the next thing that we tried to do was to develop the muffins that you see here. And these muffins actually contained bananas, banana peels, and the whole banana. So the flesh with the peel. But the success in this particular product was that we tried to adjust the color of the product so that it wouldn't be very different from the control. You could see we only had differences in the color A of the inside of the muffin, and I'm not showing the outside because these did not differ significantly. And we also had some changes in the moisture and the springiness. So in this case, we had a ranked preference test, and we found that actually the sample that was mostly preferred was the combined sample, the sample that contained the flesh and the peel. And participants were willing to consume the product knowing it produced less waste. And when we asked them which factors were important when buying these products, actually what they said was the taste. So producing the products in an environmentally sustainable way wasn't very important for them. So the last study that I would like to show is the co-creation study. And again, I want to thank Joy for showing what co-creation is. I'm not going to show a lot of information because Shelley is in the process of publishing this work. But in our case, we had seen that the product had an important, it played an important role when the consumers, were choosing whether they would consume or not a product that contained upcycled ingredients, but also the sensory attributes of the product were very, very important. So what we did in this case, we brought people over to come up with product ideas. And we also had a presentation where we gave some information about the problem of food waste. And then we asked them to work together with the ingredients that we had. And again, as I mentioned, these ingredients came from the information that we had from the stakeholders. And they developed a number of products. They developed actually quite a lot of products, but I'm just showing you just a few here. So they were as well using personas for which they would prepare and produce these products in the kitchen. And once they had prepared the products, we would all sit together and taste the products, and they would have discussions on whether they would make them again or whether they would buy them if they found them in a shop. And some very interesting comments that we heard was that my original concerns about using this material are now gone after having the co-creation experience. And I would make this product again, or I did not expect it to taste so good. I'm not so sure about the term upcycled. So what Joy has found, it is also confirmed in our study. And the safety, again, was a very important issue for our participants. So in our case, the co-creation was used in a way that can help the participants become more familiar with the idea, and possibly as a way of educating them on the materials, on the products, but also on ways to manage food losses and waste at home. So from what I have shown you so far, you can see that the consumers are willing to consume upcycled foods, but when they actually taste them and when they experience them, or when they participate in the creation process. And the product type is important. And of course, the sensory characteristics are important. But, you know, from the studies that we did with the provision of information, we have to be very careful on what information we need to provide to the consumers, so that we ensure that they will not lose their trust in the food industry, and reassure them that the products are safe. And yes, it is. I think the term upcycling is something that consumers in Ireland are not familiar with. And Joy showed that some of her participants mentioned, it's a term that we use with furniture, and yeah, that was the same reaction with some of our participants, furniture or clothes. So that's it from me, and thank you very much for listening.
Perfect. Thanks, Maria. That was very interesting. And I guess what's nice to notice is that you know, we're both in the same country, and we are, you know, carrying out similar research, and topics are coming up. Even although we carried out more in the Dublin city area, you carried out probably more on the Sligo area, but similar kind of concerns or similar comments. So it is quite it's quite interesting. I have a quick question on your study, the 2B study where you gave the information and you saw that there was actually a negative impact of information. What kind of information did you provide? Because depending on, you know, the words that you give, you say you mentioned byproduct. Maybe that's
Yes, that was the term that we used. And just let me I can share this with you if you don't mind. So I can show you the exact wording that we used. I don't know if you can see it clearly. So this is the terms. So if you were told that the smoothie is made from fruit and vegetable peels and trimmings generated during food processing, how willing would you be to consume it? So this is the terminology, that this is these are the words that we used for this particular study. But yeah, it resulted again in a reduction of willingness to consume.
Yeah, it is interesting because I guess it is quite neutral the way it is formulated, but I wonder if people maybe associate. Did people explain why? Because I guess from a consumer perspective, I guess maybe people were thinking pesticides or I don't know. Was that the concern?
Well, we have so much data, qualitative data, because we were asking them to tell us why. And indeed, safety was one of their concerns. Processing as well was another concern, because they considered some of these products over processed. But safety was one of the most, you know, of you know, their concerns. And this was actually something that we found among the Greek and the Irish consumers as well. So safety is a big issue, and something that wasn't very evident in the surveys was that people were concerned about the sensory properties, but not so concerned about the taste. So I didn't show these results. They were mostly concerned about the texture or the appearance, whereas when, of course, they were tasting the products, so in the studies 3, the set 3 of the studies, they were the comments regarding taste were you know, more prominent. They were the ones that they were more often used. But in this case, safety was a very big issue.
Okay, no, that's interesting, and I think that's something that we should maybe emphasize or say that we don't really take for granted, but we should kind of push on the concept that upcycled food is safe, has to be going under kind of the same regulation and the same it has to be safe for human consumption, and I guess that's what is also in the Upcycled Food Association definition, where they talk about verifiable supply chains and all of that. So I guess it's about reminding consumers that yes, it is maybe a new concept, but it is also safe, and depending on what kind of information we give, obviously we do see very, very important differences. So thanks, Maria.
No, thank you, Simona, for asking this question, because the certification is so important, and it would be worth to investigate how consumers view this certification to see, if this would change their perception. So yeah, thank you for asking this. Maybe something to think, to work on in the future together. So.
Perfect. Thanks a million. There is a question here. I can see I can ask it directly. So was the negative result in your consumer willingness to consume the same across product types? So, or was it different depending on the product? Were people more or less inclined to consume the product?
No, it wasn't the same. So like that's for sure. It wasn't the same for all products. So there are differences on how willing people are to consume the products before we give them information. And then there are differences on how willing people are to consume the products after we give them information. So it wasn't the same across all products.
Okay.
So for example, like just from memory, for the smoothies, after the provision of information, they were less, there were more people concerned about the smoothies, maybe because they wouldn't go through another processing
Cooking,
step. Yeah, exactly. So
yeah, that's exactly the point that the comment, the question here is making. So maybe a fresh product could raise maybe more concern compared to a more cooked product like a muffin or something like that. Perfect. No, it's interesting how the type of food as well has an impact on how much people accept them or not. Well, thanks a million, Maria. That was extremely interesting, and I'm sure we'll be in touch again because we keep working on this.
Yes.
And I think we'll move on then onto our next speaker. Thanks, Maria. Our next speaker is Margot Krzywonos. I hope I'm pronouncing that more or less okay. She's a full professor at the Wrocław University of Economics and Business, and she specializes in circular economy, sustainable food system, and waste valorization. And her research actually focuses on consumer acceptance of upcycled food, and also innovative pathways for agri-food byproducts. And so we're really happy to have Margot with us. She's bringing obviously a different perspective. So far we have talked more from a food science perspective. So now we have the more the economics and the business. So thanks, Margot, and feel free to share your presentation when you're ready.
Can you see my presentation?
Yes.
Okay, thank you. Thank you for having me. Yes, I will show you a little bit different perspective because I will not talk about the consumers, but how to combine the perspective consumers and producers. So, why? Because consumers say one thing and producers and policy makers said another thing. So whether upcycled food succeed or not, it will depend on how well we correct this perspective. So this was focus of my research. So when we when we talk about upcycled food is called as a triple win because it reduces waste, it creates value, and supports sustainability. but still, the market has been slow to gain the real traction. The reason is simple, because innovation is advancing faster than consumer acceptance. As we heard from the previous speakers, this has really happened. So to scale up upcycled food, we need to understand not only what consumers want, but also how the experts, such kind of the producers, policymakers, and scientists evaluate the same factors. So in my study, I combined the consumer research with the Delphi panel of experts. And here was involved producers of milk, the vegetables and fruit producers, and also the oil producers, so, and food scientists, and also the dietitian. And they evaluate the same factors as the consumers. So the goal was simple: to compare how both groups view the same factors and what shape the willingness to pay and attitudes toward upcycled food. So what happens? As we see, we have both points of agreement, but we have also the differences. At the center, it was the trust and transparency, and but the way how the both groups valued was very different. For consumers, the value was the taste, the health, and the clean labeling. For the experts, they value the most the system. So it was the regulations, certifications, and the supply chain innovation. The gap was very clear because consumers look from the personal relevance, and the experts emphasize structural conditions. So, but still, we can find some kind of alignments. Both groups agree that trust and transparency, what we have in the center, is the most important, and these things, it's non-negotiable. So both groups recognize the power of emotional framing, whether it's highlighting the environment benefits or telling the compelling stories. What was the barriers? The most important was that consumers hesitate to see upcycled food as a waste. It was the same as we can heard from the previous presentation. And also for the Polish consumers was the definition and what upcycling, which is not so obvious for Polish consumers, also for Polish producers. Experts, meanwhile, point that it should be more collaboration, and also there's a limited infrastructure. So if we will survive this obstacle, the market might grow. But what does it mean, and what to find, how we can transform these findings to scale up not only to Polish results, but also to food, to the world. What does it mean in practice? First of all, the most important is communication, because consumers want immediate value. So we should, when we communicate, to pair the taste, the health, and a message with the environmental benefits, rather than relying on sustainable alone. So the second one is the policy. Trust depends on clarity, and this was very true for both groups, or for consumers and for experts. So standardized and certified labeling can reduce the confusion and make some kind of the upcycled food feel legitimate. The third was collaboration, and both groups just said that there's no single actor, and the single actor cannot scale up the market. So it will take the partnership across the manufacturers, across the researchers and policymakers to move from pilot projects into the mainstream adoptions. And when we talk about the consumers' motivation and stakeholders' priority, when this meets, the upcycled food has the power to move from the niche to the mainstream, and this really happens when we close the loop in food processing. This is only the preliminary research, so I do not have more, but I'm just willing to share what we have on Polish market, because we have the upcycled food just has the negative connotation, and more often is used as zero waste. It's not so easy to translate it. And we even try to think about the word which might be more useful, but still there's a lot to do on the Polish market. So thank you very much. This is only in brief what's going on in the Polish market, but yeah, that's it. Thank you.
Perfect. Thanks, Margot. I mean, from your personal experience, what do you consider are the biggest, let's say, barriers in Poland, and do they differ compared to the other ones that we mentioned in Ireland, for example?
I do not see any difference, because we still people still do not understand the terminology. So when we communicate as a waste, they don't willing even to try. When we talk about the trimming or peels, this is not the way how we can communicate. So we have the same problems, even more, I would say, because of the terminology and the language.
Yeah, so I mean the translation, you mean, of the actual upcycled word into Polish, I guess is similar with Italian or French or any other language. You have to find a similar word that kind of delivers the same meaning, but it's not necessarily possible to do that.
Yes,
so,
yes. So it's maybe it's just better to communicate that this is nothing wrong with this food. It's still tasty, but sometimes more nutritional. But yeah, it's I found only one company which communicate what they are dealing with the word upcycling. Some they use zero waste, and other they do not even put on the label that they use, for example, some I know it's legal, but still they do not. They put fruits, not the peels from the fruits. So this is how it goes.
Okay, perfect. I get it. And I have another question. Do you know of any upcycled foods in Poland?
The typical upcycled food is the carrot cake, where they use the pressed cake, and we have also the beer from the bread. So this is the most typical, and the company is working on Poland. So they communicate the beer and the distillate from the bread as upcycled food. This is the one.
Okay, perfect. I think I did come across in the past some kind of upcycled defatted flour from maybe rapeseed oil production that is kind of converted into a powder. Don't know if it was
but
Poland.
this is they do not communicate as upcycled food.
Okay.
Yeah, we have some, but there's not clear communication that this is the upcycled food. Yeah.
Okay, perfect.
Thank you.
I'm getting a comment here on the chat. Apple pomace powder. Yeah, but not communicated as upcycled food.
Yeah.
Okay.
Yeah.
Okay, and what is your research then doing next?
Just to go deeper, because it was only the small sample, so I would like to make the bigger sample with the producers, and also try to find how to call better the upcycled food in Poland, if there is any better word. Yeah.
Okay, perfect. So you mean kind of scaling up your research and doing it with a bigger range of people.
Yeah.
Okay, perfect. Well, thanks a
you.
lot, Margot. I think we are ready to move on to Ítala. Perfect. So Ítala is currently a Marie Curie postdoc at the University of Córdoba in Spain, and she's also the co-founder of the natural upcycled bio-ingredients. It's called Vida Nubi. And so she researches upcycled agri-food byproducts and how to transform them into functional ingredients for sustainable and health-promoting foods. She coordinates also projects that are based between in the EU and Latin America, and she also works on her works basically brings together green processing technology, bioactive compound, and as well functional product development. So thanks, Ítala. The floor is yours. Feel free to share your slides with us. Thank you.
Hi, everyone. Good morning. Thank you very much for this kind introduction. So let's share my screen. Okay, everybody, it's possible to see my screen? Yeah. Yes?
Not
Still
yet.
loading. We'll give it a second.
Yes.
Oh, there we go. Let's see.
We can see two screens. I can see two screens.
Let's see. Now it's okay?
Yes.
Perfect. Yes.
Okay, thank you. So let's start talking about just a little bit regarding the upcycling the future. I will talking about specifically olive pomace as a next generation gluten-free functional flour. I'm a principal investigator from University of Córdoba, more specifically with a Marie Curie fellow. And I'm also co-founder of Vida Nubi. And it's a pleasure to be here today to present a little bit of this project. I will introduce myself just a little bit, just to you understand more regarding my background, that join science, sustainability and innovation. I am a food engineer. I have a master's degree in food safety, in food quality and safety. I have a post-graduation in nutrigenetics and in nutrigenomics, and a Ph.D. in pharmaceutical sciences with specialization in nutrition and food chemistry. All of these studies, the master and the PhD, were developed in the olive oil field. And now I'm a postdoctoral research in University of Córdoba under the Finance for Health project. There I study olive oil and olive oil byproducts and the health benefits, the health composition of these olive-derived products. And this year I'm starting a new project, namely Vida Nubi, granted by EIT Food, that I have a pleasure to be co-founder and the CSO. I also a young representative. I'm also a young representative by FAO, representing mainly Portugal and Spain. So let's start talking about the world olive oil scenario and the global production, the main countries that produce olive oil, and we will talk later regarding the olive pomace production, taking account the olive oil production, olive pomace generation in this sense. So the projection for this year, 2025, is 3.35 million tons of olive oil produced in the whole world. Spain is the leader in this sector, And it's possible to see that we are facing an increasing trend in this year regarding the previous year. We will observe more 33% regarding the comparing with the last year. As we can see here, it's possible to see the main countries that produce olive oil, and Spain is the leader so far, and we have more. It's more pronunciating in European countries, Mediterranean region. I'm trying to. Okay. Sorry. As we can see, the drive in the global, the globalization here in the olive oil sector. And sorry, I will exclude. Yes. As we can see in this slide, it's possible to see the main presence of olive oil production in the distribution in the whole world. 70% of the production is concentrated in the European Union. And this sector represents a key factor of the agro-industrial and social and economic development of these main regions. For example, in Spain, and we have a strong economic power regarding olive oil and olive products in this country. And the world olive growing covers more or less 11 million hectares, with Spain, the main country and produced olive oil, accounting for 2.7 million. And this kind of production movement an annual revenue about 7 billion euros in just in European Union. So let's talking about a little bit regarding the olive oil production and virgin olive oil production, the extraction process mainly, to try to understand how we obtain this olive pomace. So first of all, we have the harvesting process, and then the washing, the cleaning process, the leaving and pruning, and then milling, the greening, the part that the olives will crush it, and then the separation process, malaxation process that forms the oil, and then the separation process. In this separation process, it's possible to observe that we have different aspects. For example, we have a traditional one, two-phase decanter, and a three-phase decanter, and depend of this extraction process, it's possible to obtain different byproducts. If we extract olive oil with two-phase decanter, we will obtain in one side olive oil and the other side wet olive pomace. If we extract in three-phase decanter, we will obtain olive oil, dry olive pomace, and olive meal wastewater. So it's different, and the byproduct is different, and we should treat these byproducts differently regarding the extraction process. In Spain, the main country that produces olive oil, we have mainly 99% is two-phase decanter, so you have olive oil and wet olive pomace. Okay. But okay, so the amount of olive pomace generated regarding the each liter of virgin olive oil, it's huge. It's large amount. Globally, olive oil industry generates approximately 15 million tons of olive oil pomace every year. Because if we are increasing the olive oil production globally with the the worldwide spread olive oil in the world, because now it's not possible to see the olive oil just in Mediterranean countries, but other countries in US, for example, California starts the production, in Brazil starts the production. So Australia as well, countries outside the Mediterranean are starting to produce olive oil because the demand of this olive oil, the increased consumption is demanding the increased production. So as we increase the olive oil production, automatically, consequently, we will increase the amount of olive pomace production. So these kind of byproducts represent nearly 8% of the total olive fruit mass. So to produce 1 liter of virgin olive oil, we generated more or less 4 or 5 kilograms of olive pomace. It's a large amount of byproducts generating mainly in the Mediterranean region, mainly in the European Union, but we need to take into account that the other countries, US, Brazil, and Australia, are emerging producing these virgin olive oil, and we should take into account and looking for the manners, the best ways to upcycle these byproducts to develop new ingredients, new products, as we talk later. So here we have some specific problems associated with the generation of these byproducts, because if these byproducts is delivered in the environmental without the properly treatment, we observe different impacts, mainly environmental impacts, such as water pollution, greenhouse gas emissions, and mainly phytotoxicity. So we need to treat these byproducts before to live in the environment or in the nature. And on the other hand, it's possible to observe an economic inefficiency when we discard it, because we have a lot of bioactive compounds there, as we see later. And this underutilization is economic inefficient, and the regulatory operational costs, because at this moment the olive oil mills need to pay to treat these material, these byproducts, or need to pay to other industries and collect these products of the olive oil mill. On the other hand, we have here a large bioactive composition of the byproducts present in olive oil. It's possible to see that we have olive pomace, olive cake, olive stones, leaves and pruning, and olive meal wastewater, as we can see in this figure extract from scientific paper. And these specifically authors evaluated the amount of the phenolic compounds and the bioactive compounds in these different metrics. And here it's possible to see the distribution of the compounds regarding the specifically byproducts. And as we can see in olive oil, we have 4.4% of phenolic compounds. And in the residues, in byproducts, we have 95.6%. So if we know that olive oil is a health source of fat, and one of the main figure of Mediterranean diet, because of the phenolic composition and the antioxidant properties, we see that residues and byproducts have too much more content of these compounds comparing with olive oil. Here it's possible to see the richness of byproducts found in the byproducts, phenolic compounds, dietary fiber, triterpenes, lipids, and very good fat acids and tocopherols and vitamin E. So here we present some chemical structure of these main compounds, and here it's possible to see hydroxytyrosol, one of the most known phenolic compounds from olive-derived products. And the solution that we found to these two big concerns, the main one, the environmental problems, and the other one, the economic inefficiency to discard these byproducts, this large amount of generated byproduct, is the upcycling, the olive pomace for new applications, such as development of high-value functional ingredients. And it's possible to observe that emerging technologies increase the extraction process, and it's possible to obtain enriched phenolic compounds, products, the separation, the fractionation process, micronization process, enable to obtain a different ingredients and very rich ingredients in phenolic compounds, fiber, and remain lipids. And it's possible to integrate these ingredients in functional food and to develop healthier and more resilient and circular food systems. Other situation that we can explain here, and it is other kind of justification to upcycle this kind of byproduct. In one hand, we have the bioactive composition of these generated byproduct, and on other hand, we have a global food crisis challenge. We have the gluten-free products, most of them ultra-processed, and with lack of nutritional density and contain minimal fiber and low protein content. And on the other hand, we have the global lower daily fiber intake. Most of the global average, in fact, it's lower than the recommended by the World Health Organization, as we can see, 30 grams. So we have here a huge opportunity when we're talking about upcycled ingredients. We have the gluten-free market. More or less 70% of population needs gluten-free diets, or taking account the celiac disease, or taking account the sensitivity. We have the gluten-free market increasing trend. We have here some numbers that showing the increasing trend of this specific market. We have the potential to upcycle an untapped resource. As we talked before, as mentioned before, more or less 8% of olive pomace is still channeled into low value uses, such as biomass energy or bulk composting. And we have here the opportunity to integrate in circular economy, supporting different SDGs such as 3, 9, and 12. So let's presenting the power of the olive pomace flour. Most known benefits is regarding the fiber content and the phenolic composition. We have, for sure, it's possible, it's important to mention here that depends of the olive cultivar, we have more or less fiber contents. But here, in average, it's possible to see that olive pomace contained more or less 45 and 6% of dietary fiber, and a large amount of phenolic compounds, mainly hydroxytyrosol. And the hydroxytyrosol is very known, taking account the EFSA approved health claim. Now we have, since 2012, we have EFSA approved health claim. It's a unique polyphenols health claim established by EFSA. It's regarding hydroxytyrosol. And we have essential minerals, and we have also oleic acid in this flour. And for sure, it's gluten-free flour. Here we have some studies demonstrating the feasibility to use olive pomace flour for food applications. I will show different studies. It's possible to see in the literature a huge, a large amount of food application taking account of the olive pomace. We have biscuits application with different amounts, with different concentration, 10%, 20% of olive pomace replacing the traditional flour. Most of the studies here that I will show you, it's not gluten-free products because the authors replace the traditional flours and include 5, 10, 20%, depends on the study. And the last study that I will show you is specifically gluten-free, proposing using the olive pomace included. We have here pasta application. This one is a Portuguese study. They use olive pomace dried at 70 degrees for 24 hours. And it's possible to obtain that this pomace is rich in vitamin E and phenolics. And the enriched pasta showed increasing trend in fiber and phenolics, flavonoids, and it's likely higher energy, taking account the amount of lipids in this flour. We have residual lipids in this flour, good ones, but we should take in account. And it's possible to observe that appearance, color, and aroma were positively, but regarding flavor, they noted persistence, and the textures were impact. And the authors advised the using lower levels of olive pomace in this study. We have other study taking account the breadsticks application. So it's possible to see here that these breadsticks were enriched in fiber comparing with a traditional one. And in this case, lowered energy. And this here we should take in account the type, the kind of the olive pomace used. Most of them defected more, the olive pomace. Other ones have more remained lipids. So taking account the different olive pomace used, it's possible to see more or less energy, taking account mainly the remained lipids in these byproducts used. Other bread application, here we have some interesting images, and we can see different percentage of olive pomace used, and different cultivars used here. And taking account the different cultivars used, we have different results. And it's possible to see that 1% of olive pomace powder in bread formulation showed similar technological and sensory quality to the control bread. So as the advice in the other study starts including lower amount of the olive pomace in the formulation, it's possible to obtain better results, mainly in sensory analysis. For sure, if you will analyze the antioxidant capacity, the phenolic composition, as higher as the amount included, as higher as the concentration of the olive pomace in these products, it's possible to obtain healthier products. But we should take in account, we should considering the technological aspects and for sure the sensory quality of the products developed. Here we have other studies. As you can see, we have several studies in the literature trying to include these olive pomace in different products. Here we have a 10% formulation, 15% formulation control, and 5% for formulation. It's interesting to see the color change, and for sure the texture changes and all the aspects of gelatinization and technological process of these technological parameters of these developed products. Muffin application. So here we have two additional ingredients, not only the olive pomace flour, but also extra virgin olive oil included in this kind of product. Optimized muffins showed higher total dietary fiber, ash, and lipids with lower starch. Total caloric value remains similar to the standard, indicating feasible partial substitution of these traditional flours with olive pomace flour. And here we have a study, a gluten-free study using olive pomace. Here we have specifically information regarding the olive pomace used. 70% of fiber contained in olive pomace, 10 to 30 lipids, and up to 98% of olive polyphenols remained in the olive pomace. So the olive pomace used were freeze-dried, milled, and sieved, and contained lower 7% of moisture, and for sure safe to food application. Taking account the gluten-free formulation, the olive pomace were included to replace rice and corn flour, and the authors use xanthan gum to improve the texture and the technological properties of these products developed. We can observe some nutritional improvements, taking account lipids, fiber, total phenolic contents, and antioxidant activity. Technological and sensory enhancements, better crumb structure, lower firmness, and appealing chocolate-like color. The color is similar to chocolate. And the better performing blends. Here it's possible to see that authors improved the specifically grains and the replacements 50% with 50% of corn and 50% of rice. A large amount of olive pomace flour comparing with the other studies, as we can see. Now I will talk just a little regarding our project, Vida Nubi, our technology, our innovation model, and some products that we are developing in this product. Our main differentiation of our products is the SARS partnership. We directly collaboration with olive oil producers. We have a long-term agreement. We work closely with these producers, so we have fresh olive pomace taking account the production, distribution, avoiding logistics and complexity. Our technology platform, we have a proprietary cascade processing that maximize the value and maximize the extraction, and it's possible to obtain different ingredients from the same raw material. We work in a B2B integration, ingredient as a service model that supports food manufacturers and with technical expertise, but not only food manufacturers, but also cosmetics and the nutraceuticals applications possible to use. Just a brief regarding our process, our proposed process, cascade bioprocessing pipeline with zero waste approach target. We work on low temperature drying, precision micronization to reduce the particle size. This particle size reduction enable us to apply olive pomace and olive pits in different meanings, such as food and including cosmetics application. Our strategic fractionation process enable us to obtain rich extracts, phenolic-rich extracts, namely in hydroxytyrosol, and enable us to obtain solid fractions such as olive pit and olive pomace flour. And we have quality optimization, hydroxytyrosol concentration and standardization in the extracts, increased fiber content in the pomace flour, and the higher shelf life of the raw material obtained. Here we have some images of the project and the studies developing under this main idea. We have a strong partnership with Unicamp in Brazil. Now I'm developing prototypes using extra virgin olive oil and the olive pomace flour, very rich in phenolic compounds and fiber. And we are developing new products with these materials, these ingredients. And I'm testing it in taking account consumer acceptance, nutritional profile, lipid oxidation, phenolic composition of these products developing, color analysis, and mainly anti-glycation effects, the possibility to avoid the formation of ages, harmful compounds that are formed during the cooking process. And we are evaluating how these extra virgin olive oil and the pomace flour can avoid the formation of these harmful compounds, taking account the antioxidant properties of these compounds. So I'm evaluating crackers, sticks, gluten-free ones. It's possible. It's important to mention using chickpea flour and in alternative way replacing using 10 and 5% of olive pomace flour in these products developed. Here we have a global collaboration networking and taking account academic excellence. We work close with European and the Latin America research. We foster next generation food startups through this open innovation and the technology transfer. And most important, the policy integration, because we are engaging policymakers to create supportive frameworks for circular economy implementation. We have a challenge for sure regarding novel food regulation, but we are working closely with these regulatory pathways to prove that olive pomace is safe to food applications and we can commercialize these products, because all of these studies that I show, the studies is in lab level. We are demonstrating that it's possible to use this olive pomace flour to substitute to replace the traditional flours and to develop nutritious meal foods. But we have this situation regarding the novel food regulation. We have some market validation. A gluten-free bakery market represents significant commercial opportunity, and we know that gluten-free market, to sum up with sustainable and clean label market, are huge. So we have a big opportunity here. And the other opportunity is the EFSA health claim, because we know that this olive pomace contain hydroxytyrosol, and hydroxytyrosol is already validated by EFSA. So we have support, but we at this moment are facing novel food regulation that we can that we should first apply and receive the positive feedback from them, mainly taking account EFSA and FDA.
Sorry, Ítala, just to wrap up, please, because you're going over time. Thanks.
Yeah, just to conclude, the future is circular, and what if behind every drop of olive oil there was a sustainability story to be told? We have olive oil, but we also have olive pomace, and we can upcycle these byproducts to develop new functional ingredients. Please, if you want to know more regarding these products, the Vineland products projects, please contact me. Scan this QR code to contact me in LinkedIn. And thank you very much for your attention.
Perfect. Thanks very much, Ítala. It was very interesting to see the different applications. I think we might have a quick question there on olive pomace. What does that include? Does it include the olive stones?
No. In fact, the olive pomace flour, we remove the stones. When we obtain from the olive oil mill, we obtain olive stones, the remaining lipids, and the pulp. But to apply it in that studies, all of them that I show you, first of all, the stones were removed, and then we keep just a fine powder to include in the food products.
So it's mainly the pulp and the skin then?
Yes, exactly.
Perfect. Okay. Thanks very much, Ítala. It was lovely to listen to all the different applications. I think in the interest of time, we'll just have to move on to Jessica, but thanks a lot.
Thank you very much. Thank you.
No problem. So last but not least, obviously, we wanted to keep you until the last European presentation. So Jessica Aschemann-Witzel is Professor of Marketing and Consumer Behavior and the Director of the MAPP Center at Aarhus University. And all of us really know her research. She studies sustainability transition, technology adoption, and also the consumer citizen perception towards novel products and practices. So thanks, Jessica, for being here, and feel free to start when you're ready.
Jessica, we don't have your sound yet. Let's do a little troubleshooting. No luck yet. No, not yet.
Can't hear you, Jessica. No.
There we go. Now you're here.
Perfect.
Yes.
Okay, then it's not the external microphone, but I hope that works well enough.
It's coming
Yeah,
through
we can
clear.
hear you well. Yeah.
Okay. um,
All set.
so now you can
Wonderful.
see me and hear me.
Correct. Thank you so much.
Perfect.
Okay, good. Can you hear me also clear enough?
Yep, coming through clear.
Yes.
Okay, great. Okay, thanks a lot for having me. And it's really nice also to meet a lot of colleagues here because this upcycled food area, research area is sort of a small area. So it's really nice to meet the others, and thanks for organizing this. So I wanted to share a few things, a few of my thoughts on upcycled food and some of the research areas that we have been working in at MAPP. So I wanted to first say something about the trend and where I see sort of the definition coming from that we talk about, sort of this two-sided definition. Then I wanted to say something about what I see as a big hurdle, and that is actually a clean label, where I see that as a big hurdle in sort of how to talk to consumers. And then I wanted to say what I think is sort of maybe a two-sided strategy if we take food systems approach of how companies can communicate about this, but also changing the communication over time and adapting it to different contexts. And then I wanted to mostly talk about different alternative ways to go in communication. So Emily already said you introduced me, so that's really nice. So I'm working at the MAPP Center. I do most of my research in marketing and consumer behavior. And we are sort of working at a business school. So that's also why my focus is very much on what can companies do and how can they work with this. And when I say we, I mean the MAPP Center. So my colleagues that are also on the first slide, they are also here at the MAPP Center, and we do sort of social science research in the food context in the food sector. And I hope you can find us on LinkedIn and follow us there. So what I wanted to say about the trend is a lot of you have already talked about the environmental background and why we need to tackle food waste. And I especially like this study here because I was looking into the different ways of approaching that. We have a gap between how much food we can produce and how much we need, and the different ways of tackling that. And one is sort of reducing the demand, and that is what we do if we reduce food waste. But the other is sort of filling the production gap, and that is using resources more efficiently. And the definition of this upcycled food directly taps into these two ones here. So when we use food that already is produced and we avoid losing that, then we are reducing the demand by making sure that something that already is food is actually used. And when we are using underused resources, like what Ítala was talking about, then we are sort of doing the second one of these two different ways of filling the gap. So that's why this definition of upcycled foods that we have been introducing of saying there's upcycled food by upcycled food in an alternative use sense, sort of taking something that already is food, rescuing it, and then making into new food. That is sort of tackling the first gap, and the second gap is tackled by those upcycled food in a novel use sense, avoiding food waste by broadening the food resources and using all those interesting underused nutrients or ingredients and making that into new food. So that is, for me, what is most important, where these two definitions come from, and where it's important to sort of look into food waste and avoidance of food loss in these two different ways. And now sort of saying something about Denmark, we've been looking in a report in different years and asking people about the familiarity with the concepts, and we found, even though, I mean, change in consumer behavior is always really slow, but we could actually see that there's a significant change in the term of upcycling becoming more known to consumers. So that is kind of a good sign. So we've heard a bit about examples of upcycled food in Poland and in Ireland. In Denmark, there's also a range of really nice companies working with this. Brewers Brand Grain, there's a company, a grain, working on this. There's another company making vegan flødeboller. It is a very Danish thing, sort of using chickpea water. And there's also a company using sort of spent coffee and selling boxes where you can grow mushrooms on this. And then Denmark is surrounded by lots of water, so there's also seaweed. And there's a company working on using seaweed for products. So there's a lot of really nice examples of companies working with this in Denmark. But what I see as a big hurdle in consumer behavior is the following. So it's a slide with a lot of different concepts here, but across decades of consumer research, we can really see there's again and again consumers preferring something that is natural. Consumers preferring something that is clean label, even though they might not use that concept, but that is sort of what comes through in consumer research. We've already seen in what Joy was presenting that consumers are concerned about the processing. They don't like ultra processing. If something sounds familiar, they're not sure if it's safe. They maybe rather want to have something from a smaller producer than from a bigger producer. Lower price, it should be convenient, but ideally everything also from unspoiled nature. And all of that, you cannot have everything, kind of. And I think that's kind of a big hurdle because consumers want all of this, and it's not that easy. And if you try to communicate about upcycled food, things get more complicated than that. So these two pictures here are two examples because products like Fiji water really sort of show that people want to have something from unspoiled nature, but at the same time, this would be very unsustainable if everybody buys this type of water. And the eggs here is an example from there was a scandal about PFAS being found in organic eggs, and then people saying, oh, I cannot even buy organic eggs. But actually that would have been the one reason for buying organics, that they want to reduce pesticides in their products. So I think that's quite of a big hurdle, and we've been working a lot with system thinking, and I think when one looks at system thinking, one often sees that if one works with those causal loop and with system thinking, often the idea is to maybe try to find out what are the different solutions to a problem, and might there be solutions that are not just treating the symptom, but maybe also are more fundamental. Because if you maybe have a solution that just treats the symptoms, you maybe have side effects that make the fundamental solution more difficult. So to give an example from the food waste area, when we are selling food that is reduced in price, that's a really good idea to treat the symptom of food waste. But at the same time, we know that consumers get the perception of lower value of this food. So in a way, it's kind of also maybe disturbing the fundamental solution, which would be that people value food more. So there can often be sort of different types of strategies, and they can have negative side effects maybe on the longer run. And when we work with system thinking, we often also see, okay, there must, if we really want to have high leverage and change something, it is, you need to sort of go deeper and maybe change something about mental models. So mental models is also when you work with consumers in the longer run and maybe work on what they're aware of. And what Joy was talking about, the co-creations, it can be maybe something to do in order to change how people perceive this. So this is a quote from a book that I really like, that I think is interesting because it kind of changes our mental model of what are we and what is the stuff, the ingredients that go through us. But to go to the next point, and that is this two-sided strategy that I wanted to explain based on the idea of looking into system thinking. And that is, if we take this idea of their symptomatic ways of solving something and there's fundamental solutions, if we look at food waste, I think that companies should think about, okay, there's different situations where you really need to work with consumers as how they see things right now. that is sort of more short-term and close to the current product and the current situation. So you need to look into the right target group and what is the best USP, unique selling point to this type of group, what appeals to them. And that is also what the type of research that we've seen today is sort of working with. What do consumers want right now, and how can we appeal to that and sort of communicate maybe that also on the product packages. And that makes a lot of sense because we know from segmentation, targeting, positioning, we have to find the right target group, and we want to communicate to these to really make it easy for those people to understand what would be a good reason to do that. But we also at the same time know that maybe this is sort of, this works when we sort of really communicate on the product in the shopping situation. But if we want to change something about the problem in the more fundamental, we also need to work with maybe changing how consumers think about something. And that is where I say that maybe sort of the whole sector in a long-term strategy can also think about how can we maybe sort of trigger maybe changes in consumer perception. But that can only be done more with the whole industry, maybe using the backside of products to maybe question a bit how consumers think about this, and to build some support for future products. So things that consumers don't eat today and would not like to have in the product, but those are maybe ingredients of the future. And when sort of the backside of packages, when people are in the situation where they really process and think more about this, and that changes their fundamental ideas about what is edible or not, then maybe they're sort of, that is preparing the future opportunity for new products. And that idea is sort of based on that we know that there's different moments where different types of processing are more important, system 1 and system 2. So if we are in the supermarket and we look at the front of pack, we are maybe sort of more in the system 1 processing mode. So we kind of react to what immediately interests us, and we are sort of more likely sorting products away that don't appeal to us. But when we are at home and we look at the back of pack, we are maybe more in the rational thinking mode, and then this can sort of, there we can maybe change attitudes by explaining how upcycled food is a big concept, and this way paving the way for future products that are maybe not that easy to communicate on the front of pack yet, or in the normal shopping situation. So that's sort of my way of taking food system thinking and saying how can we sort of both work on the now but also work on future products and build maybe acceptance into the future by thinking about these different ways of communicating the overall issue as well as sort of the specific product to consumers. So I was saying that I wanted to especially talk about those alternative ways to go in communication, because we have been working on different other concepts that are maybe understudied yet. And we have been looking at consumer research, and Maria was summarizing that also very nicely, that the consumer research that we have so far, we know that there's certain consumer characteristics that explain which consumers are more open to those products, that neophobia has a role, innovation orientation, there must be an ingredient product match, familiarity with the product. So these are sort of the factors that explain what consumers like and how they react, and what explains who reacts more positively. But this is also especially environmental concern. And I think my point about upcycled food is that in upcycled food, there's maybe a few other options that other environmentally good products maybe don't have, but that upcycling could have, even though it's not that easy to communicate upcycling, but there's a few other ways. And I've been trying in different research to look at different of those alternative ways of communicating upcycling. So one of that is that in already published work with a few further colleagues, we were looking in surveys in different ways of communicating products. So in 5 different countries, 500 consumers in each country, and then we showed different upcycled food concept and product examples, and then we explained the product in different framings, so different unique selling points, putting either climate contribution, the environment on the forefront, the frugality as an aspect, or simply talking about that the product is designed to be tasty. And then we asked about attitude, and we asked for open comments, people explaining the concept to a skeptical friend. So here's sort of the comparison of how we phrased the environmental and climate aspect versus how we phrased or framed then what we called frugality. So it's kind of a concept about that contains different things, also a bit of a tradition, but also simply using what we have as a frugal way of doing it. And we found that frugality was faring slightly better in communicating and increasing positive attitude. So based on that, we would say that frugality is a way to go in communication, and that can be done by upcycled food because there's a reason to argument that upcycled food is sort of tapping into frugality based on what it is actually about. We were also asking consumers about their own way of describing the concept, and here's an example of one of those statements that consumers made, sort of taking their own background and then saying, okay, how they kind of understand that, and in a way putting it into a traditional context and saying we've always done it like this, and that is simply traditional in a way. So this is sort of one option of communicating upcycled food. But then we've recently been looking into another concept, and that is food nostalgia. So we have a good colleague from the psychology department, and she's working on nostalgia. And we thought that maybe food nostalgia could also be an approach. And the reason of thinking that is because nostalgia research shows that triggering nostalgia or feeling nostalgic can lead to high acceptance of new products. And here's an example of something that I found on LinkedIn where someone was talking about seeing bread and sort of talking in a very nostalgic way about the bread that you know from where you come from. So there is some kind of nostalgia that can be triggered about food, and we thought maybe it could be interesting to see if that can help communicating upcycled food and increasing acceptance of upcycled food. That research is unpublished. It's part of a Norwegian research project on bread and rescuing bread. And here we did a survey study where we looked into younger adults and their reaction to 3 different repurposed bread products, so repurposing old bread and putting that into new products. And we had a between subjects design where we had some consumers being primed to feel nostalgic by writing about an event reflection. So writing about an event where they are nostalgic versus an event where they're not nostalgic. And if you think what does nostalgia mean? So that is a sentimental longing, a wistful affection for the past. So you can see in the definition of nostalgia in a way it's maybe a bit part of the frugality that we are using earlier because it's sort of about the tradition, but it's a different feeling. So it's a different concept here. So what we found out so far is that this manipulation actually worked. So those who were primed to feel nostalgic also reported higher feeling of nostalgia, but it didn't have an effect on the acceptance of these 3 different concepts of new products that we were showing to people. But we still believe in that concept and that it could maybe be an interesting way of going in communication. So we are planning a follow-up study where we then look into nostalgia in a different way. So we are going to do advertising of food nostalgia advertising, and so trying to test it in a different way. So now I was talking earlier about system thinking, and in this study, as well as in another study, we also had been looking into system thinking and trying to study system thinking among laypersons. And I know that Maria and Shelley, you have been working about sort of the circular product concept, and I think it kind of goes into that direction. So we had been working into seeing if there's a potential role of system thinking capacity, and how can we sort of maybe find out about system thinking. So we did a qualitative study in a recent project. That is a quote from a participant that is presented in the report that we did from the project, because it is about consumers engaging with upcycled food, and that we asked them about how they understand upcycled food in the food system and how they think about it. So that's an example where a person is elaborating about circularity and how that is sort of visualized and how they kind of imagine and perceive that to be. That was an intervention studies where we had consumer citizens. They got a product box. They participated in 2 excursions. They got weekly emails with some information and quizzes or videos from different upcycled food companies. And we did interviews before and after the whole journey where they kind of learned about upcycled food. We wanted to know how they conceptualize circularity in food system and understand upcycled food. But we haven't published it yet. So that's some kind of, we have the impression that we can get some idea about people conceptualize circularity. And this we want to use in order to draw some conclusions of how you maybe should communicate circularity in order to sort of tap into what consumers think about circularity and how they can envision circularity. But in the other study that I mentioned earlier with the young adults who eat regularly bread, where we studied that with Danish and Norwegian consumers, we, apart from testing the food nostalgia, we were also looking into whether a system thinking capacity measurement that we had, whether that is a better explanatory variable for the attitude towards the upcycled food. And of course, so here also we were expecting and also found that the environmental concern explains a positive attitude to the products, but we wanted to see how maybe system thinking impacts that relation and what is the role of system thinking. So we found, for example, here that the Norwegians had a higher system thinking tendency than the Danes, and we found, as we expected, that environmental concern increases the attitude. So when people are more environmentally concerned, they're more likely like upcycled food. But we also found that system thinking capacity mediates that connection. So it plays a role in this whole interaction. So that means it could be interesting to communicate and appeal to system thinking when explaining upcycled food. That's also not yet published. So we are working on getting that into a publication to read more. So what I wanted to present to you is sort of how something about the trend and why I think that based on the gap between what we produce and what we need to produce and the different ways of addressing that gaps, that taps into the definition of upcycled food. I think there's a sort of a big hurdle if you look at consumer behavior and what we really know about consumer behavior, because there's a lot of those different terms and the natural trend to naturalness. So there's a lot of that makes it actually difficult to talk about upcycled food, because you cannot just, because there's processing involved and maybe food waste involved, and that could be sort of contradictory to the trend to clean label and people not having sort of wanting unspoiled products. Based on the system thinking, I think there's a two-sided strategy in communication that one can use, thinking about what is the long-term impact on changing consumer behavior and what is sort of the short-term action in order to tap into how consumers think right now. And then we were looking into those different alternative ways to go in communicating upcycled food. So going further than the environmental concern, looking at whether frugality could be a way to go, which we think it does. Food nostalgia, we think could be a way to go, but we haven't found proof yet in our studies. And then also system thinking capacity playing a role and being relevant here. Thanks a lot for your attention.
Lovely. Thanks, Jessica. That was a very nice update on your research and the next things that are coming up on upcycled food. So that's nice to hear. I have a quick question on what do you think is the future of upcycled food, whether it's in your specific country. Where do you think efforts should focus? Should it be on the communication side, or should it be on the legislation? Where do you think the biggest gap lays?
Yeah. It's a difficult question. I think in general, maybe, I think there's also a lot of trend to sort of look into the labeling and sort of looking into certification. But in a way, my fear is that with all the research that there is about eco-labels, that there's so many different labels, that there's a lot of competition in the label market. Mm-hmm. And that maybe that extra effort
gets confusing.
Yeah, it can be difficult. So I think that maybe sort of the more general communication is especially relevant. That doesn't mean that a label does not help. And I know that a lot of our producers in Denmark also would like that. But at the same time, generally knowing the research on consumer eco-labels, that I think sort of maybe the more general communication and working on the general trend of accepting the concept, I think that has an even bigger impact maybe.
Perfect, thank you. And other quick question I had was on how the upcycled food word kind of translates into Danish. Is it a straight translation? Because I know in Italian or as we saw earlier in Greek or in other languages, it can be kind of difficult to even translate the whole concept. So does it work well in Danish?
Yeah, I think in Danish, but that's maybe a specialty of Denmark, there's a lot of English words. So actually we were using a Danish word, but an English word at the same time. But in the project in Norway, the Norwegian don't like to add English words to the language. So they actually have, and they are using something that is more like recycled. And that's also what we did when we were translating that earlier to Portuguese and Italian. And that of course is sort of that makes it less comparable, but it's simply an adaptation because there's different words used in the different languages that then the local researchers say, but that's how we communicating right now. So, but of course it's not the same, because if you look in the definition of upcycling, it doesn't make sense to say recycling, because the idea of upcycling is something different than recycling. But that's simply, one has to adapt what maybe is on the market and in that language. But you're completely right. That's something a bit confusing about trying to translate it to different areas.
Yeah, absolutely. Thanks for that. And then finally, you talked about messaging and frugality and what is it that works and what is it that doesn't work. And is there, do you think, one specific type of messaging that works for most people, or do you think it is the tailored approach, the one that we should go for, depending on specific demographics? Then specific messaging have to be developed.
I think that's maybe a question of the market size, because I mean, of course, right now, upcycled food is maybe a small market, and it is actually and I think I expect right now there's a big overlap between the people who buy upcycled food and the people who are the environmentally concerned, that are sort of meet all the stereotypes of what also the results typically show who are sort of the most likely consumers. But when the market is growing, I think that upcycled food has the option to appeal to some other groups who are maybe sort of more like the idea of, but that's how we've always been doing. It doesn't have to be that complicated. So I think this may be a question of the market size and where a certain product is. So a big producer might want to sort of go to some communication that goes further than a certain target group. If it's a smaller producer, it makes sense to keep to sort of that group and that demography.
Absolutely, yeah, I would agree with that. And I guess you will have, different resources if you have a big company or if you have a small company. So I guess that also has a big impact. So yeah, thanks a lot for your presentation, for your updates. And I guess we could be here talking about the differences and our opinions for hours, because it's such an interesting topic. But I guess we're just bang on time with the end of the European session. So I'll just hand it back to Amanda, and thanks again, Jessica.
Well, thank you to all our European presenters. Thank you, Simona, for orchestrating us so well. So many themes of yesterday and our June conversation that just came up in all those presentations. So really invite you to look back on those past presentations, and we'll keep weaving this all together. So many subtle nuances. And one thing that's on my mind a lot as we talk about segmenting consumers and purchasing behavior, with pet being such a fast-growing category in upcycled food, how do pet purchasers, or maybe your cosmetics or home care purchasing with upcycled ingredients, how might they differ from kind of your traditional grocery purchaser? So I'll plant that seed. As we wrap up our European section, want to drop a few opportunities in the chat and on screen. I'll invite Simona back on for just a moment. Simona, if you want to talk about your opportunity, and as I drop the link in the chat here.
Yes, of course. Yeah, it's just a quick thing that came to mind. That we have this special issue going on in Wiley is actually a collaborative special issue between two journals, and it's actually on upcycled foods specifically. So if you are researching in the area and you have some manuscripts, could be a literature review, could be a piece of research that you think might be suitable, just keep an eye on it and keep in touch with me if you want to know more.
Great opportunity. Thank you. And we'll make sure to share
Thanks.
that link and follow up as well. And then also wanted to share and excited to announce that in December, in terms of our European gathering and community, we're excited to be, grab my screen share here. Excited to be a purposeful partner of Food Ingredients Europe this year. So looking forward to that in Paris in December. We'll have two of our emeritus board members representing for UFA. So Dr. Jonathan Deutsch, who's been co-chair of this initiative, gentleman in the jacket there, as well as Sue Marshall, who's one of our founding board members in the white jacket there. So look forward to them being on site in Paris in December. This QR code here links to a lunch and learn. They're going to be hosting one of those days. So I would invite you to attend if you'll be there, share with your networks. And then one other initiative that will also be spotlighting at Food Ingredients Europe, we closely collaborate with Food Valley in the Netherlands, and invite you to check out here, as well as highlighted in December, their global food upcycling map. So that's a really great moment to think about how to collaborate from every corner of the globe, as we've been discussing. So more to come on that. So we are going to transition in our tight schedule here and welcome to stage our Canadian section. So really pleased to be bringing here on stage Dr. Alex, who's been really helping lead with Vineland Research, bringing together the countrywide upcycling community of Canada. That was a spotlight of Upcycled Food Month this June, and she presented in our June symposium as well, and really excited to have Alex co-hosting this section, as well as beginning us with the presentation here. So Dr. Alex, over to you.
Hey, thank you, Amanda. So welcome to the second half of today's symposium. And as Amanda mentioned, all of us in the second half of the day are either Canadian researchers or we have a fair bit of Canadian research experience. So I wanted to provide some context about upcycling in Canada before we start. For those who don't know, the agri-food sector is a very important sector in Canada. So for example, Canada is the top exporter of canola and the third largest exporter of wheat in the world. And the agri-food sector accounts for 7% of Canada's GDP. Now, for comparison, in the US, the agri-food sector contributed 5.5% to the GDP. And in the EU, that number is 3.5. And so clearly, although we have a reputation for being a pretty cold country, we're still able to grow quite a bit of and manufacture quite a bit of food. And so because of that, because we have this large agri-food sector, we also have access to a fairly large amount of byproducts from farms and from food processing. And our government has also been quite supportive of efforts to valorize agricultural and food waste. And so as a result, we do have a pretty good burgeoning upcycled food industry here. And today we'll be focusing on some upcycled food research highlights, mainly on plant agri-food research highlights. So to kick things off, I'll be presenting some of the research that my colleagues and I have been working on over the past couple of years on functionality of upcycled fruit and vegetable powders in food formulations. The next, we'll move on to a presentation from Dr. Andrew Tait about upcycling for the nutraceutical industry. And then Dr. Xiumin Chen will be presenting about the use of coffee leaves in beverages. And then finally, our last presentation of the day will be from Dr. Emily Steliodis, with a discussion about food informatics, which I'm really excited to listen to because that's a completely new topic for me. So a lot to look forward to today. For now, I'll kick things off with a presentation of some of our research here at Vineland. Just going to go ahead and share my screen. How is that? Are you seeing the correct screen?
Yep, go ahead.
Okay, great. So a bit of introduction about Vineland. We're a Canadian organization dedicated to applied horticulture science and innovation. And so the focus is on applied research, which means that we always work very closely with industry. We're a research services provider. We do grant-funded and contract service research, but we also, whenever we have a project, we virtually always work with a company that drives the need for the research. We're an independent not-for-profit, so that means that we are not government, we're not academia, and we're also not industry, which sits somewhere in the middle of those three categories. And our mission as an organization is to improve the economic viability, sustainability, and competitiveness of horticulture in Canada. And in case you're not familiar with the term horticulture, it's a subset of agriculture where I like to describe it as everything that's colorful in agriculture. So it's fruits, vegetables, flowers, trees. We don't deal so much with the beige crops like the grains and so on. In terms of research capacity, we have a 218-acre campus, and we do call it a campus because we have 35 buildings, including research labs, research farms, and research greenhouses. We have about 100 employees, of which 60 are in R&D. So as you can imagine, we have quite a wide range of expertise on campus. I have some photos here featuring an aerial view of our facilities. We have a picture of our robotics example. Our automation team developed a cucumber harvester. We have people in our biochem lab on display here and our sensory lab as well. And as I mentioned earlier, in terms of our mission, part of our mission is to improve the sustainability of the horticulture sector. And we do this through examining environmental metrics of the industry, looking at soil management practices, climate adaptation, working on pest and disease control using non-chemical methods, and also waste valorization as part of that portfolio. And so in the waste valorization space, we've worked on projects that focus on ingredient development and also opportunity scoping and playing a connector role within the sector. So we've worked with growers that have, or companies that have byproducts available and are trying to figure out what the best opportunity is to utilize it. We've also worked with ingredient companies that have a concept for an upcycled ingredient in mind, but need help with finding the right source of the raw material that they could upcycle. We've also done quite a bit of work in sector overviews, looking at sources of byproduct and industry-wide challenges and needs. Now, shifting to the upcycling space in Canada more generally, last year, Second Harvest, which is an organization in Canada that focuses on logistics for food donation charities, they put out this really great report where they try to quantify the sources of food loss and waste through the Canadian supply chain. And what they found actually echoes what was found in the presentation earlier this morning, talking about the situation in Ireland, where, again, people tend to think that the end user, so people at home, are a major source of food waste, when in reality, the largest sources of food waste are actually pre-retail. So in Canada, 2/3 of waste occurs before retail through primary production at farms and also through processing and manufacturing of foods. And so if we really want to have a huge impact on reducing food waste and upcycling, the focus really needs to be on engaging the industry in upcycling. And in Canada, nearly 1/3 of this pre-retail fruit and vegetable waste is what's termed unavoidable. So it's waste like peels and pumice or grayed outs that necessarily come off the raw material as you're producing other products. And so these byproduct streams are recurring. They're fairly predictable volumes seasonally as well. And we all know that they're rich in antioxidants, hydrocolloids, and antimicrobials. There's years of scientific research that support that they have all these interesting components. They're well documented. However, there is a knowledge gap that's still preventing a lot of these from being commercially valorized. And some of that knowledge gap is around validating these functionalities in real-world formulations at realistic concentrations that are palatable. And so there's definitely a need for more sensory testing, more palatability testing, and just validating and verifying they actually work in real life. And so for today's presentation, I'll be giving 2 examples of exploring this missing link on the path to commercial valorization of byproducts. And the first example will be our work in looking at native texture modifying enzymes in fruit and veg byproducts, as well as onion antimicrobials. Starting with the enzyme work, so the specific type of enzyme we are looking at is a class of enzymes called transglutaminases. It's also called TGAs for short. Transglutaminase is a very long word, so I'm going to just say TGAs for the rest of the presentation. And they are ubiquitous in nature. They're found in the human body, they're found in animals, they're found in plants. They're also produced by microbes. But commercially in the food industry, they're usually derived from microbial fermentation or cattle blood fractionation. And they are a protein cross-linking enzyme. And so what that means for food is that they're used in the industry for binding and gelling. They're used sometimes in low-fat yogurts to increase thickening. They can be used in bread dough to stabilize the dough during bread proofing so it doesn't collapse. They're also used in a lot of plant-based products. So for example, if you've had scrambled eggs, plant-based scrambled eggs, they're typically made with TGAs. So are many plant-based hot dogs. If you've ever had surimi, imitation crab meat in your sushi, then that's also made with TGAs. So there's many examples of TGAs used in the industry. But back in 2005, this publication came out that showed that apple pumice contains TGAs, and they freeze-dried the apple pumice and then added it into a pork sausage formulation. And I found that once they were added to a pork sausage formulation, it improved the firmness of the sausage, instrumental firmness of the sausage. And that caught our attention. We thought that was very interesting. But since then, in those 20 years, there hasn't been any other research that dug into this more deeply and tested plant-based sources of TGAs in formulations. There's only been research that said that there is TGAs present in various plant sources. But the reason it caught our attention is that there's many advantages of potentially being able to use upcycled powders as a source of TGAs. For example, dried powder production is for sure less costly than existing commercial TGAs alternatives, because microbial transaminase, first of all, requires fermentation, isolation, and then conversion, drying to a powder. Whereas, for example, in apple pumice, you just have to collect it and dry it and mill it, and now you have an apple powder with potential TGA sourcing. They're also clean label. In Canada and the US, TGAs, if it's added into a product, it has to be listed on the ingredient label as transglutaminase. Whereas if you're adding in a dried apple powder, you can just list apple powder on the ingredient list. So our objectives for the research were to firstly validate the literature findings of there being TGAs in apple pumice in freeze-dried samples. But we expanded that to also include 12 various types of fruit and vegetable byproducts. And so we sourced byproducts from various fruit and vegetable processors around the province, and we tested them for TGAs activity. And then we chose the ones that had the best activity and moved them forward to the next phase of testing, which was to examine enzyme stability and to look at the conditions for enzyme activity and temperature tolerance. And then those that performed best at that stage were then dried using more commercially relevant drying methods. Because of course, freeze drying, although it's very good preserving functionality, it's quite expensive and it's quite difficult to translate that into commercial application as a food ingredient. And so we tried it using different methods. And then finally, the ones that performed the best had retained the most activity at that point. We moved forward to sensory testing. So we then dried the material and added it to plant-based patty formulations to see how they impact texture. And the sensory testing is what I'm going to be focusing on for today. We added various fruit and vegetable powders to plant-based patties at a concentration of 1.75%. And the two examples I'll give today is apple pumice and onion peel powder, which we dried and incorporated into these formulations. We also had control samples that contained either 1.75% maltodextrin or MTG. So MTG is microbial transaminase. And maltodextrin was meant to be our low texture modifying control. It's more used as a filler, whereas MTGase is supposed to be our high texture modifying control because the typical microbial transaminase that's used in the industry. And so these are the results of our sensory testing. We used a method called relative to reference. And what happens in the relative to reference sensory test is panelists are given 2 samples at a time, one control sample and one test sample. And they're asked to indicate how they compare in terms of specific sensory attributes. So is it more cohesive or less cohesive than the control? And we, of course, had our low texture modifying control samples as one of the, these are all blind taste evaluations, and also our high texture modifying control. And we also included an MTGase sample that was blinded to test to make sure our results were valid. And so presumably it was just being compared to MTGase to MTGase. And so because it's close to the x-axis, So it means it's very similar to the control sample, which it should be because they're the same. And that just means our results are valid. And what you see here is where we have an asterisk is where we have significant differences. And so we found that the maltodextrin sample was significantly different from our MTGA's control sample, which is good. That's what we were expecting. And our apple and onion containing samples were not significantly different from the MTGA's control. And so we found that the maltodextrin containing sample, the plant-based patties were sort of pasty, gummy, whereas when you added apple or onion or MTGAs, they had a higher tendency to crumble instead of being pasty and gummy. And they also were less adhesive, so they didn't stick to the surfaces of your mouth as much as the maltodextrin sample. And so overall, when you added apple pumice powder or onion peel powder, the patties behaved more similarly in texture to the MTGA's control. And then we also did the same testing, same samples. We tested them with the texture analyzer to further corroborate the results. And we found that, again, the apple pumice powder and the onion peel powder were not significantly different from our MTGA's control. And they were different from the maltodextrin sample. And so overall, we found that the upcycled fruit and vegetable powders show promise for use as texturizers in plant-based patties. And their effect on texture was similar to the MTGA's control. But of course, apple pumice and onion peel are complex systems. We didn't isolate these enzymes, and so we can't confirm for certain if the observed texture effects are directly from the native TGAs in the powders. We did try to select powders that had more TGAs activity, but we would have to do future work to better understand how much of the contribution to this texture is from the native TGAs in those samples. I would also love to be able to test them in various additional formulations to further explore their effects on texture. Moving on to the second example is talking about the byproduct antimicrobials. So we all know that onion and garlic are very well known for having antimicrobial properties. And so it always was a bit striking to me that there isn't a lot of as far as I know, there aren't any products in the market that are onion-derived powders, specifically for the purpose of shelf life extension. And so when we dug into the literature, we saw that there's still quite a few knowledge gaps. Even though we all know that they have antimicrobial properties, there wasn't a good understanding of what the sensory differences are between onion powder and onion peel powder. There's also a lack of information about how the drying method could impact sensory properties. And there was some microbial challenge tests. For example, they looked at when you have a microbial challenge test, what that means is you're adding an ingredient to a food formulation, then you're inoculating it with a pathogen like E. coli or Salmonella, and then seeing how effective it is at suppressing those pathogens. And there were some microbial challenge tests in the literature. However, there was no clear understanding of what if they're being done at realistic concentrations because there was no palatability testing done. And so their concentrations in some of these tests ranged from 0.5% to 12%. And I'm not sure if 12% is a very realistic concentration for onion powder in a food formulation. So what we wanted to answer is what is a realistic concentration? And we wanted to work with breakfast sausages because breakfast sausages tend to have a pretty mild seasoning. And so it can be seen as a bit of a worst case scenario where the onion peel powder would be pretty obvious pretty quickly. And so we did paired preference testing with consumers where we presented consumers with pairs of samples, the onion peel powder containing pork sausages with 0% onion peel powder versus increasing concentrations of the same powder. And the presumption was that initially, as you add a little bit of onion powder at a time, that it would improve the taste perception because, of course, it's a seasoning. But eventually it would reach a threshold where it becomes too much and starts to have a negative effect on consumer preference. And what we found was that the threshold was around 1.43%. So it is fairly low as a concentration. So, but we wanted to move ahead with that because that's what seemed to be really realistic. And so we took that concentration and we used that concentration in microbial challenge tests. And we worked with our project partner, Product International, who did the microbial challenge tests. And we provided them with the onion peel powders, which they incorporated into pork sausages. We had 4 types of test samples. We had the control with no onion added. We had the commercial onion powder that was off the shelf. We had onion peel powder prepared by one drying method and onion peel powder prepared with the second drying method. And then we examined the effect of onion peel powders on bacterial suppression of spoilage bacteria, a cocktail of Salmonella, and also a cocktail of E. coli. And what they found was that all the onion peel powders and also the commercial onion powder exhibited antimicrobial properties, but the onion peel powder was the most effective. And so you can see that by day 21, there's a 1.5 log reduction in the number of spoilage organisms in the pork sausages compared with the control sample. So that's quite a significant reduction because it's on a logarithmic scale. And in fact, at GPI, when a product has below 6 TPC, so less than 6 total plate count of spoilage organisms, they don't consider that product spoiled yet. So by day 21, the pork sausages containing this onion peel powder with drying method 2, they still were not considered spoiled. When we move on to looking at pathogen suppression, the results were a little bit different. They weren't as exciting. You can see that, first of all of the samples, the Salmonella counts do reduce over time, even in the control sample, which is expected because as spoilage organisms grow, they produce lactic acid, and that lactic acid has an effect on suppressing pathogens like Salmonella or E. coli. And so what we're looking at here is how much our test samples reduce Salmonella compared with a control sample. And in the first 5 days, the control sample had the highest reduction in pathogens because of the high amounts of spoilage organisms producing more lactic acid. However, from day 7 onwards, the results were more comparable. And so there aren't a whole lot of differences between the different samples, which in itself is pretty interesting because, as we know from the previous slide, the onion peel powders had a pretty significant reduction in the spoilage organisms. So despite the fact that there's less competing spoilage organisms and less lactic acid available, there's still some suppression of E. coli and Salmonella. So the key takeaways were that the threshold for consumer reduction of breakfast sausages with increasing amounts of onion peel powder was relatively low at 1.43%. But the exciting part was that the onion peel powder had potential to be used as a shelf life extender, even at this low concentration. And so presumably if you're adding it to something like a more seasoned sausage, you could possibly even add even more onion powder and have potentially more effective suppression of microorganisms. So they were quite effective against spoilage organisms, but a little bit less, had minimal effect on pathogens. So overall, there's a great deal of research showing that fruit and vegetable byproducts contain valuable components, but despite this, commercialization has been limited. And part of that could be because there's a need for more research bridging the gap between fundamental science and commercial application. And so I was really pleased to see how much research there is happening this morning using sensory, using food formulations. I think we're heading in the right direction, because there is a need to validate functionality in food formulations and include more high quality sensory testing and use real concentrations that are palatable to consumers, and also to determine what those concentrations actually are. Because if we have a better understanding of how byproducts contribute value, that can justify higher value pricing for upcycled ingredients, especially if they contribute specific functionality. Because then they could replace other more expensive ingredients, and that could incentivize their use by CPG formulators. Because so far, that's one of the challenges that we keep hearing, that upcycling can be a challenge to make them financially feasible. And so if we can demonstrate their value, it can justify better pricing for these upcycled ingredients. And so today we gave examples of how apple pomace powder and onion peel powder exhibit texturizing potential, and onion peel powder could be used as a shelf life extender. I'd like to thank everyone who contributed to this research. We had a big team at Vineland who contributed to this, from our sensory team, our biochem team. We also had our partners at Gum Products International, Thomas Wu and Henry Liu. Thank you. I'm happy to take questions.
Yeah, I think Andrew has a question. Go ahead, Andrew, if you want to go off mute.
I do. Thanks, Alexandra, for an interesting talk. Of course, we're all preaching to the choir here because we love to hear these success stories of how useful these ingredients from upcycled sources can be. Now, you answered my question right at the end about the use of the onion peel powder in breakfast sausage, right? Because it's sweet, it's got a very distinctive taste. Now, I'm curious if you are able to use those results from your client project to then do what you had suggested, which is then apply that peel powder to an onion flavored sausage.
You mean in terms of the flavor profile?
Yes, like for another client, like, so is that sort of just focused on that one client project and you can't use the results elsewhere, or now that you have this knowledge, you have free reign to sort of help others with non-breakfast sausages?
Yeah, so that was actually like a joint grant-funded project they're participating in. So being a grant-funded project, we do have more flexibility in terms of using that information. And they've been really great about being open to sharing that data in publications or in presentations. And so that is definitely data that we can use more broadly. And through this research, because we're doing sensory testing, we also happened to we were able to get insights about the flavor profiles that these powders contribute. And often it's not always what you expect. In some cases it can be, but for example, the apple pumice powder, we add that into the plant-based patties, it didn't actually contribute an apple flavor to them. And we saw that previously. A few years ago, we did some research on apple pumice in yogurts. We added the apple pumice to a strawberry filling. And again, it didn't give an apple note to the strawberry filling. And so I know it's pretty subtle, the apple flavor, although it could contribute more like cardboard or, kind of plant type attributes. Whereas the onion peel powder, we actually found that depending on how you dry it, if you dry it certain ways, it can taste very similar to traditional onion powder.
Okay, so how able are you, this is the second question, how able are you to then translate those results to a health benefit? Because if there are antimicrobial properties, then you're thinking maybe there is a pathway for prebiotic effects and so on.
Wow, that's a great question for you, actually, Andrew. So I think, there's probably definitely a lot more research would have to be done to test that in real clinical trials, or I know there's a lot of tests done in petri dishes, which are not always translatable. And so I think the next phase, if you wanted to make it into a health product, you'd have to move on to something, more realistic, more validation, but more validation on the nutraceutical side rather than what we've been doing on the food side of things.
Yes, you have to
I'm not
keep
sure if you
within
have
the
any
scope.
thoughts on that from your experience in the nutraceutical
absolutely.
industry.
Yeah, thank you.
So no additional questions at this time. So I think, yeah, we'll transition over to Andrew.
Okay, maybe I'll introduce Andrew first then. So thanks, Andrew, for joining us. And Andrew is an entrepreneur and researcher bridging traditional medicine, modern science, and sustainable innovation. And as a founder of Tait Laboratories, Inc., he pioneered the upcycling of citrus peel into MS Plus, Mandarin Skin Plus, a natural digestive aid that has reached thousands of people across North America. So please welcome Andrew Tait.
Trying to figure out what the best way to share my screen would be. Okay. How's that? So yeah, you can.
It's all coming through. You're good to go.
Great. Okay. All right. Well, you can. Well, first of all, thank you, Alexandra, for that introduction and for being part of the larger Upcycled Food Association team. Lara and Amanda, thank you all for being here and contributing to this community. And I'm not sure if you could see my shirt. It's bright orange. You might be thinking it's on brand. I'm Actually, today is Orange Shirt Day, or the Day of Truth and Reconciliation. It's a national holiday in Canada, and it's to pay tribute to the lost children, to the archaic residential school systems, and their families and ancestors. So this talk is coming to you from the Laurentian area north of Montreal, and I acknowledge it's the unceded ancestral territory of the Algonquin Anishinaabe Indigenous peoples. So as I transition into the main content, I just want to set the intention for what I'm about to share with the question that we can undo, or how can we undo the loss of ancestral knowledge, loss of traditional herbal medicines that may have been deemed waste or useless in the name of profits, of colonization. I think we all have the ability to engage in this conversation and see a light at the end of the tunnel to rectify some of the decisions made by our ancestors. So clinical trials are very important for proving how things work. And on the subject of colonization, a lot of the trips across the Atlantic Ocean from Europe to the New World were made possible because of this very first clinical study by James Lind. And you can essentially sum that up with the understanding that most people did not make it across the Atlantic, the thousands of miles. This would have been one of my ancestors that survived, but maybe some of his friends suddenly disappeared, not lucky enough to make it, but they suffered bleeding gums, painful abscesses, and eventually succumbing to the lack of vitamin C in their bodies, because we didn't know that it was important for a diet of healthy fruits and vegetables. And that disease, scurvy, was predicted to take the lives of about 1 million British sailors in the 17th and 18th centuries. And because of this first clinical study, we were able to understand that we could use not only fresh fruits and vegetables, but that citrus fruits in particular were much higher in whatever they deemed to be that active component. And it took a while, but the British Royal Navy made carrying lemon juice a requirement about 50 years after that clinical study. But indigenous peoples knew about this and shared that knowledge since Jacques Cartier's time, which was 100 years before. So it was about 200 years since it was first known from initial colonial activity. 40 years after that clinical trial, and then 1 year after Dr. Lind's death. But fast forward, 1930 is when vitamin C was discovered, and 1937, the Nobel Prize in Physiology or Medicine was awarded. And essentially, we now know that vitamin C is important for us, but it is something that's known that scurvy could be making a comeback in certain populations that are at risk in modern day times. So I'd like to tell you about my origin story. I accidentally was studying multiple sclerosis. I mean, I wasn't accidentally studying multiple sclerosis, but I was studying multiple sclerosis and found that there was a link to citrus peel as a potential source of compounds that could be a remedy for multiple sclerosis. But looking at this initial clinical study, if we now know that vitamin C, it's contained in the fruit, but if you have double the content in the peel, then if the peel is something we throw away, could that food waste, could that be then considered medicine? So when I was studying multiple sclerosis, just a refresher, in case you're not aware of how that pathophysiology works out, it's the installation on nerve fibers that breaks down, and you end up getting plaques forming in the brain that can be seen by MRI. And essentially, you get a lifelong path of disability. And I was studying the pathway on the right, potential viral triggers that would interact with this very important pathway for keeping the myelin healthy, keeping it wrapped around the nerve axons. And in that initial study, it was seen that it was a hodgepodge, an herbal mixture of about 14 herbs and spices in traditional Japanese medicine. It's called Ninjin Yoito. And this traditional Chinese variant, Renshen Yang Yingtang or Renshen Yang Rongtang, had the pretty much the same herbs and in the same proportions. And that was seen to improve the health of MS model mice by increasing the number of myelinated neurons and also the thickness of that myelin on the neurons. But the question was it a synergy of all of these herbs together somehow, or was it an individual herb that was acting on its own molecular contents? And so it was found out in a subsequent study that came out 4 years after the original one that it was the citrus peel that contained compounds like hesperidin and nerirutin that can help the precursor oligodendrocytes to differentiate, form mature myelin by stimulating that important pathway that I spent several long years studying for my graduate studies at UBC. And so once that pathway is stimulated, you have the mature myelin forming, and I started asking, can we make a medicine from this? And it turns out that there was a lot of reluctance in discussing this, or B, that it was just disgust, like thinking that this is something we throw away. This food waste could never be medicine. But I'm here to tell you that I see a pathway forward that it could be taken as a developmental pathway for medicine. So what's in the peel? We heard from a lot of speakers talking about the benefits of polyphenols and other phytonutrients, but the peel has vitamins, minerals, fiber, a lot of other compounds that have potential prebiotic properties. And we've been particularly interested in the polymethoxylated flavonoids. I know some of you purists out there would say, well, hey, bioflavonoids and polymethoxylated flavonoids are polyphenols, but I meant that those two are separate, and the polyphenols are there's a lot more that could be contributing to the activity of the peel. Now, following the trail of where the best peel could come from, we actually had some anecdotal evidence in an N of 1 trial on an MS patient. Some naturopathic doctor friends of ours essentially got that herbal formula, that 14 herbs and spices, as I said, and they were able to see recovered mobility in one of the patients that had relapse remitting MS, and essentially got back 100% of his mobility. But they said, the naturopathic physicians, that they would like to find a high quality source, like the highest quality source that was around. And that led me to find that Xinhui, China produces the most culturally revered source of material. And it is much higher in the PMFs than any other region that has been studied and published on. And we now know that the practice of dry aging, careful selection in that region increases the PMF extraction efficiency. And you see, like champagne, it's got that brand recognition that it is really potent. So also, the older the peel, the more expensive it gets. And the science behind that is that the matrix of the cellulose and the other fibers tends to break down, making it easier. Once you add time and the sunlight drying, you get more into the beverage that you'd be making, the essential tea. So right before pandemic times in 2019, we had a trip to Xinhui, China, when there we could see just how they would dry it, and the whole industry. It's a $4 billion US industry. It's centered around keeping the peel and throwing away the fruit, and that runs counter to what we would consider normal practice in our Western world, and yet there's thousands, hundreds, if not thousands of dollars per kilo of value assigned to this ancient herbal formula. So on the left, you can see that that's a sample of one of 3 samples of the oldest peel that's been validated. There's no price on that. It's a museum piece. And on the right is my better half, and she's holding a jar peel that's as old as she is. So we wanted to get the most out of the peel, understanding that it really isn't a matter of one particular compound. The literature was saying there's a lot of things that could be working synergistically, and we do have a lot of peel waste that's produced, 32 million tons annually, and probably about 4 to 5 million tons of that is citrus reticulata, which includes like mandarins, clementines, all tangerines, so the smaller varieties. And we developed a method just using water, heat, pH fluctuation that we could have a tunable way to extract more of the good stuff, more of those compounds of interest. We had patents granted on that. So when I say tunable, what we can do is get up to 50% yield of the dry peel that is high in fiber and polyphenols and also water soluble, but we tweak the conditions and we can also have a relatively high yield of hesperidin. And as you recall from the previous slides where I showed that was one of the active components deemed to be important for improving the health of those MS model mice. So we were slowly edging our way there, and we really were trying to figure out how we could validate this now. And our next speaker is Xiumin Chen, and she was instrumental at conducting some of the studies that we performed on our brown powder, right? So we could increase the yields, and people were asking, well, can you sell it? Can you tell us more if it's safe or not? And so we initially tried to get funding using the DSS model mice. And that's a model for inflammatory bowel disease. And the funding agency was very hesitant to go down that path. They did not want to explore a disease indication, but luckily we had found probably an even better opportunity to work with Xiumin Chen, who's our next speaker today. I'm grateful that we were able to work with her during her time at UBC for her postdoc in David Kitt's lab. Without her, we wouldn't have this wealth of data to show a lot of different beneficial properties of the peel. And not only that there really was a trail showing that you didn't have to get this expensive peel from Xinhui. You could look to other regions as well. Of course, the branding suggests that Xinhui peel is the best. It's the milieu. It's the only good peel. But based on these results, we saw this is just one bit of data on the inflammatory response in immune cells. You can see that Xinhui has much more of the polymethoxylated flavones compared to other regions, almost on par though with Sichuan, and you see that they all have a lot of similar anti-inflammatory activity. This is the whole peel extract, so we're wondering, is it just the polymethoxylated flavones, the PMFs, that are responsible for this, or is it a synergy with the other additional smaller polyphenolic acids, the soluble or insoluble fibers as well. And interestingly, we saw that we didn't have as much activity with the reconstituted similar levels of flavonoids only, so without the backdrop of the fiber and other compounds. And we did see, though, that there was a lot more attributed to the flavonoids that were higher in the Sichuan and Xinhui varieties. So another study that we published was looking at the tight junctions. So you've heard maybe the expression leaky gut or leaky gut syndrome, which is not a real thing, but it's been controversial over the years that a lot of people have pointed to this leaky gut syndrome as a potential underlier of chronic disease. We think that there is a mechanism there that might explain some of the chronic diseases, but it's definitely not a disease in and of itself, because we can modulate it with diet, and we see that the high PMFs of the Xinhui peel extract were very efficient, effective at low concentration at stabilizing the tight junctions and restoring the barrier integrity against an onslaught of alcohol used as the permeabilizing agent. So what we did next is, hold on, there, try to look a little bit further into what could be happening. And it turns out that it is, when I say what could be happening, I'm speaking specifically to what is responsible in the sum total of the peel extracts that help to deliver that higher amount of polymethoxylated flavone activity. What is responsible for these varieties outside of Xinhui for making more polymethoxylated flavones? And it turns out it has very much to do with the plant's PMF biosynthesis pathways. So fast forward a few years, it was discovered that the methylation is deficient in a large number of the varieties you'll find commercially. So you have a flavone core, and what happens is you have a concert of these O-methyl transferases that attach the O-methyl groups to the rings, those dangly bits there. And nobiletin is one of the most fully methoxylated PMFs. Tangeritin, on the other hand, is missing one of the O-methyl groups. And Peng and colleagues showed that the deletion of a small region of DNA was what was responsible. That region, 1041 base pairs in the promoter region of the varieties of some of the hybrids, the more modern and early cultivated types of mandarins. In this diagram, you can see on the far left, there's basically no PMFs in some of those newer hybrids that might be more, have a longer shelf life, sweeter, brighter orange, like more cosmetically pleasing, and it's sacrificing the levels of PMFs. And that deletion is mapped to the promoter of OMT4, and that's still found in some of those medicinal ancient varieties. And how we plan to use this data, you can see here in red that's actually the Xinhui level, Xinhui sample looking at the PMF content. There are plenty of others that have similar, if not more, content of PMFs that are still in the wild. The Mangshan one is the largest amount there that's boasting almost double the Xinhui content. But Dancy is commonly used in the orange juice industry, and well, the common ones you see here, Hamelin, Valencia, they do have some PMFs, but just not as much as you could efficiently get from some of those ancient, wild, early cultivated mandarin oranges. So this is some PCR data that very simply shows that you have the possibility of two different bands. So the ancient ones that have two copies of the gene, and so not missing that bit of DNA, that gives you one higher band. So that would be at the top left. And as you move down and you have that diploid where there's now two copies, one of the deleted version and then one of the full-length version. You start to see lower amounts of the PMF content being found in the peels, and then when you have the diploid of the homozygous double deletion, you have very low amounts of PMFs. But we've managed to reproduce this in our hands since last year. Part of that was funded by the Canadian Food Innovation Network. We're seeing how we can look to save Dancy before it's too late. It was once the most popular tangerine or small citrus reticulata fruit in the USA. It's no longer available except for at small nurseries. And so that's where we got one of those, and also a control, the Silver Hill Satsuma. And we were able to reproduce some of that data, and we're still optimizing. There's a reason why you still get some very faint intact bands on that sample. I won't go into today, but that's what we're working at. Some of the things at Concordia University with my new affiliate associate professorship. We are looking at how we can detect rapidly this, and also citrus greening disease. So differentiating the modern hybrids that are missing that bit of DNA, but also detecting the microbes that are responsible for creating citrus greening disease. If you haven't heard of it, it's responsible for decimating a lot of the citrus industry. It's basically wiped out 90% of the Florida citrus industry from 2008 to 2018. And right now at 2025, their production levels are at pre-World War II values. And so I put a little image of Cleopatra down there, bottom right. She's possibly, I believe, the last pharaoh. It's also the name of one of the hardy ancient varieties of Citrus reticulata that's used as a rootstock. So a lot of the mandarins that you'll have commercially grown, they're grafted onto rootstock. So the opportunity here for Cleopatra Citrus reticulata is that it can grow in a variety of conditions, and that's something that growers may want to explore commercially. So growing possibly Cleopatra fruit, not to graft, but grow it for its fruit, and that would be the primary value driver. But I'll just share real quick some of the problems we've run into with procurement in the industry. Of course, you think, why don't we just talk to orange juice companies and see how we can get their appeal? I could say we knew for a number of years now that they have a hidden cache of mandarin peels in particular. We know that it's used in flavoring, but the conversations inevitably go, I'm hoping they're going to change, but it's around that they don't have any waste, that it's sustainable, it's already being put to use, and usually that means it goes to cattle feed. And they don't acknowledge oftentimes that they include it in their orange juice. So a little known fact, it seems, is that the so-called 100% orange juice that you'll get in Canada or the United States, Canada has the worst type of adulteration when it comes to orange juice. Adulteration not meaning unhealthy, but that it's the orange juice is adulterated with mandarin juice up to 15%. In the US, it's up to 10% mandarin juice. And another problem that we run into is that the larger juice companies, they've invested heavily in infrastructure that, for example, is the screw press, invented and popularized around the 40s, and sort of framed as that environmental hero. It was able to reduce the moisture content in peel, but unfortunately, the way that the peel is treated with lye, so high alkalinity, it destroys the polyphenols, unfortunately. So we are still hoping that there could be change in the orange juice industry. We see that there could be an opportunity to grow some of these rare mandarins with some partners using the heat from server farms. That's already been shown in the Netherlands and other places, using excess heat to grow commodity fruits and vegetables. And we hope that we can explore this pathway further to change the supply chain right from the source. And a little bit about what we've done as a company. When we started and made our brown powder and took it to market, we originally thought we'd still, before pivoting, we could have a product for multiple sclerosis, of course. And our code name MS Plus, when we realized we couldn't readily go to market without expensive clinical studies, we expanded that to still keep that to pay a tribute to where we come from, but it stands for Mandarin Skin Plus. So we wound up with this very long brand name of MS Plus, Mandarin Skin Plus. But the customers that we were able to legally market it to for digestive health, we've sold nearly 30,000 bottles over the last decade. So quietly, we've done that without any major marketing campaigns, just word of mouth, and also on claims that are not very strong in differentiation of the product. It's traditionally used in Chinese medicine for gas, nausea, bloating, diarrhea. But we have been trying to build up towards a larger clinical study for years, and we thankfully got some funding from the Canadian Food Innovation Network to study our proprietary extracts. We're also building off of some clinical data that we have from a small pilot clinical study where we looked at 9 out of 10 people who have functional digestive disorder. So loose stools and those symptoms of gas, nausea, bloating, and lots of customer testimonials. But you take those with a grain of salt. That's why a double-blind placebo-controlled trial is so important for proving the symptomology reduction and also the very unique prebiotic benefits. So stay tuned for that. Here's some fresh results not seen anywhere else, not presented anywhere else yet. This is from our collaborator, Dr. Heather Armstrong from University of Alberta. We have looked at high nobiletin or high PMF and low PMF extracts, and we see that there is a distinctive advantage to having the high PMFs type of extract. And this is looking at a pool of normal patients and people with IBD, inflammatory bowel disease, Crohn's, colitis, and you see an improvement in some of the beneficial, a raise in some of the beneficial inflammatory markers, like the ones that fight infection, cancer, and have other tissue modeling properties related to anti-inflammatory processes. And we see a reduction. TNF alpha is there, and other common culprits that you see raised in some of these inflammatory diseases. So a lot of these are commonly targeted by blockbuster billion-dollar-a-year sales type of drugs. So you can understand there might be some hesitancy from key opinion leaders to support the use of just simple citrus peel extract for helping people with things like IBD. But there is a path forward. We're understanding more, especially because Heather Armstrong's group is very knowledgeable in trying to understand the aberrant inflammatory pathways that are associated with diseases like IBD. They don't respond the same way to fiber, and a lot of people are avoiding fiber consumption if they have IBD, knowing it could be a trigger. So that's a vicious spiral. These people need fiber as long as it's not going to cause them issues. And we're seeing that our high nobiletin extract, say for one sample that we looked at in a pool of IBD and normal sufferers, it really drastically reduced one of the key pro-inflammatory markers of IL-1B. We've got more data, but I can share that at a later point. Just send me a message and we can discuss. So you might think, well, that's all fine and dandy, but how would you get a product on the market for IBD, let alone MS? But there is a precedent, and it's thanks to the Canadian regulatory system, the NNHPD. The precedent here is N-acetylglucosamine for inflammatory bowel disease, where there is a claim. For those of you who don't know, N-acetylglucosamine is from chitin. 100 billion tons of chitin are produced each year. It's in the exoskeletons of insects, of shellfish, crustaceans. Most of it's recycled naturally in the oceans or in the forests. And so, yes, so second most abundant polysaccharide in nature, next to cellulose, right, from trees and plants. So 6 to 8 million tons of crustacean and shellfish waste are produced by the agricultural industries, the fisheries each year. And the claim that Health Canada has approved, and there's 7 products that have been using this one for the last decade or so, helps promote a healthy intestinal lining in people with symptoms associated with inflammatory bowel disease. And we just got, so Tait Labs was assigned, helps relieve abdominal pain associated with inflammatory bowel disease when used in conjunction with conventional therapy, based on the provision of new clinical results that were published and non-proprietary. I won't go into this in too great of detail, except to say that the Marine Institute, Heather Burke, director there, they had 4 postdoc positions, and they're still looking to fill the last 2 of those. So if you're interested in community engagement and also on the science of how you go from these crustacean waste to viable products like chitosan and N-acetylglucosamine. There's also another impact I want to speak about very quickly is the European green crab. Those were hitchhikers on those boats coming over, and they're still coming over and affecting the ecology of the local environments in North America. It's an invasive species, and millions are spent each year to try to eradicate the European green crab. But you see that there are a lot of barriers that, with more conversations, discussions with our political leaders, we can change some of the laws that could very carefully harvest these invasive species without creating problems with transfer and more loss of habitat for the juvenile salmon and shellfish. So we can eat them. They are soft shells if eaten at the right time. And you can see that that's also a benefit if we can not only eat them, but then directly use their shell for chitosan and N-acetylglucosamine. And it's coming full circle for MS because in 2023, N-acetylglucosamine was shown in a small pilot clinical study to be beneficial for people with relapse remitting MS. Mind you, they had to take quite a bit of product, 6 grams or 12 grams were studied, and 12 grams seemed to have a more dramatic effect on the disease symptom reduction, but 30% displayed some proven improvement, which is pretty huge, right? Considering this is just upcycled from crustacean waste. Now, for those of you who are curious, there is a fermented microbial source that can be made available, and there's still some regulatory red tape around that. But that said, there is hope that if you have a shellfish allergy or want a source that is kosher or halal, then you can have it fermented one day soon. I won't go too much into this, but I was trying to originally say that the analogy I was thinking about of when we use the waste in that term, us in the industry kind of cringe, and we're still looking for better ways to say, upcycled, revalorized, and it's still been a point of contention. And I was thinking, historical lenses will help guide us. The example is, I have this now collector's item toy that I got, Darth Vader from Return of the Jedi figurine. for free my last Halloween in 1990. And it's now valued minimum 500. You look at eBay, it's sometimes you'll find people selling for 2,700 or more. Now my mother would come around and throw away all the stale candy. And if I kept that toy that I had gotten with my haul from Halloween, then I wouldn't have that $500 collector's item. And you know, if she threw it away, it would be justified. It's just a dollar toy without really having the foresight that it could be worth something more. And it's almost like when we still use the word waste, that we're not willing to look in the bag and see that there's something different there, that it's just all junk food, all garbage. Like if we haven't been valuing food the way that we should. We focus a lot more these days on removing what's unhealthy. And of course, we heard from a number of our friends here over the last 2 days that there are efforts to show the health benefits, but there is still a lot of pulling punches, right? There's in vitro data, animal data, but not enough clinical data yet. But I propose exaptation as a word. Exaptation, like adaptation, but exaptation, it's usually used in a genetic context where a trait that was evolved was then used for an unexpected purpose. Like think birds that evolve feathers, you know, then it was for warmth, but then use them for flight eventually, right? So you think about that evolutionary track from dinosaurs to birds of flight. And I like that. I don't know. I think we should try it on for size. I'm open to discuss exaptation. And I just want to finish with a call to collaborate, because this is how things move forward. I originally had a few slides talking about the roadblocks that I've faced, the discussed from a number of key opinion leaders in the medical space when I tried to approach them with genuine scientific inquiry. But when I say there's a light at the end of the tunnel, I've given examples that you can make a disease claim on food or food waste, and there's funding programs to do that. But not just in Canada. I mean, we're seeing things happening in the US with changes at the FDA. And I just want to say that 2 weeks ago, the Alliance for Natural Health filed this petition against the FDA to allow 118 censored claims. One of the ones that I'm interested in and have been watching closely is peppermint oil because of IBS. And there's other diseases like vitamin D may reduce the risk of MS. So we'll see how this plays out in the next couple months when the FDA has to issue a statement in response to this petition. But I want to thank all these wonderful organizations. Not enough time to thank people individually, but a lot of these orgs have been very helpful for our progress, especially NRC IRAP, CFIN, also NSERC. A lot of good organizations have helped us along the way. And that's it. I'm happy to take a quick question or two.
Hey, thanks, Andrew. We're a little bit over time, but I will ask you one quick question, which is, you mentioned that these nutraceuticals are meant for treating symptoms of multiple sclerosis, and you now have some clinical trials underway. How close do you think you are to getting a natural health product on the market with a claim for MS?
Well, if you allow me, I'll share. I do have just a quick piece of information on that. We're not actually doing any MS work, just to be transparent. I mean, we see that there is that opportunity for others possibly to take that forward. We may get into this space, but the way Health Canada looks at it is that you need at least 2 pilot studies. Like, so we have one for digestive health, right? And you also, or alternatively need, so that's for low risk claims, but you need 2 phase 2 clinical studies. So I think we're very close to seeing perhaps another organization do a second MS trial on a small cohort. And I believe that would be enough to get an MS claim on an acetylglucosamine product. But you know, US might beat us to it. Us being Canada, right, where we see a lot of the opportunities. But you know, these petitioned claims by the ANH may open the door wide open for making MS and other disease claims.
Super. Xiumin, I see you have your hand raised. Do you have a question for Andrew as well?
Yes, I do. So,
Hi, Xiumin.
hi, can you hear me?
Yes, good to see you.
Good to see you. So first, congratulations for your new job. And then I actually have a quite interesting talk, but I have a question about that. I saw that you're showing the wild type of the plant actually has a higher like PMF, right? And then but then the modern cultivar have a lower like a PMF. Do you know that why is that? And is anything reason that during the modern the breeding that make the PMF level lower?
Yeah, so that deletion, thank you. That's a very great question. You know, and I was so excited when that Peng PNAS paper came out to show that it was that deletion. And they did some very interesting studies to really see what that effect was with a lot of different analogs and things. But essentially, it's that we don't know when it happened, but or even why it's beneficial. It might have to do with taste. Because as you probably know, the PMFs can be bitter. So you still see that the medicinal varieties still have that intact promoter region for OMT4. But when it's deleted, you see that you get, because it's citrus is typically diploid, you have these early admixtures that are considered, you know, like Dancy, you know, still widely used, but it's that that heterozygous, right? So one copy of the gene has the deletion and the other one doesn't. So then you have a mid amount of the PMFs being made.
Okay. All right. Thank you.
Thanks, Andrew. That's a great presentation. We're going to be moving on now to a presentation by Dr. Xiumin Chen about from byproducts to functional ingredient, hot coffee leaves in beverages and nutraceuticals. Dr. Xiumin Chen has a Ph.D. in food, nutrition, and health from the University of British Columbia, where she spent several years in Canada, completing her graduate studies and a postdoc fellowship. So she's an honorary Canadian for today's session. And currently, Xiumin is a professor at Jiangsu University in China, specializing in the valorization of plant byproducts for the development of functional foods and nutraceuticals. And she is ranked among the top 2% scientists worldwide in food science. Please welcome Dr. Xiumin Chen.
Okay, let me share my screen. So can you all see my PPT?
Yeah, that looks great.
Okay. So thank you for the Alexandra for your introduction. It's been a great honor for me. It's been a great honor for me to present some of my research here at the Upcycled Food Symposium today. Before I begin my talk, I would like to briefly introduce the university that I affiliated with. So here is the Jiangsu University. It's located in Zhenjiang, Jiangsu province. It's a city quite close to the Nanjing. This is can you see my pointer? My mouse. Probably I use the laser pointer.
Think so.
Here. So this is Zhenjiang, and then this is Nanjing. It's the capital city of the Jiangsu province. It is a 2-hour train ride from the distance from the Shanghai. Probably a lot of you may know this city. So the Jiangsu University has about 25 schools and faculties, and then it has over 45,000 students and over 2,500 faculties members. I am from the School of the Food and Biological Engineering at Jiangsu University, which was ranked 3rd in the best university in food science and technology in 2025 by US News. Our school has over 130 faculty members, and the current research area include non-destructive detection of the food for quality and food physical processing, nutrition, health, food safety, and biological engineering and equipment. The global production, before, like today, I would like to share with you some of my research on how a coffee leaf can be used to make beverages and nutraceuticals. So I think most of you here actually probably drink coffee or tea on a regular basis, but probably not many have heard of the coffee leaf tea. So before diving into the details, let's take a quick look at the coffee itself on a global scale. Coffee actually is mainly grown in a developing country. The color showing here is a green color. It's called major coffee growing countries. But its consumption actually mainly happens in the developed countries like United States and Canada and a lot of the countries in the European Union. So, and then the top three coffee production countries is Brazil, Yunnan, and Colombia. China is the 13th coffee producers, and the harvest area is about like 80 kilohectare. And about more than 99% of the coffee actually grown in Yunnan province here. This is the region, the major coffee growing region in China. And to increase the coffee bean yield, farmers often trim the coffee branches for the 10 and 30% of branches. But this leftover branch leaves are mostly discarded, which not only like waste valuable resource, but also contribute to the environmental problems. However, coffee leaves are far from being just waste. They have a range of the industrial applications, including like can be made into the coffee leaf tea, therapeutic agents, tobacco substitutes, and then animal feeds. Among this, most common use is the coffee leaf tea. Looking at the patterns landscape, we can see that the Japan, China, and USA holds the largest number of the patents related to the coffee leaf application. So the earliest known record of the coffee leaf tea comes from 1853 article entitled like coffee leaf as a substitute for tea, published in the Western Journal of Medicine and Surgery. So in fact, coffee leaf has over 200 years history for being consumed as a tea in Indonesia, in like India, Jamaica, Ethiopia. Nowadays, it's estimated that about 5 million people drink coffee leaf tea around the world, and it is approved as an edible food resource by European Union in 2020 and in Taiwan 2021. So here you can see some example of the coffee leaf product, tea product and beverage from the Wise Tea. This is a company Wise Tea located in originally from the Vancouver, Canada. So this except for being consumed as tea, actually coffee leaf are also utilized as a ethanol medicine in Africa, Middle and South America. Those are major coffee growing countries. So for example, coffee leaf has been used to treat fever, stomach, and stimulate prolactin, and headaches, and stomach pain, and cough, and diarrhea, and some can use for the elevate the HIV. So the impressive health benefit of the coffee leaf actually comes from their rich profile of the bioactive components, including alkaloids, phenolic acid, flavonoids, ginseng, and carotenoids, and these nature compounds actually work together to provide a wide range of the activities, such as antioxidant, anti-inflammatory, anti-diabetic, anti-obesity, and anti-fatigue. So in other words, coffee leaves are more than just a waste. Actually, they are a nature source of the compound with real potential for health and wellness. So over the past 8 years, our lab has focused on the valorization of the coffee leaf using various processing techniques. We have applied different tea processing methods, using tea processing method to process coffee leaf and examine their effect on the bioactive components and the change of the aroma sensory quality of the coffee leaf tea. We also use non-thermal processing methods such as the ultrasound to accelerate the accumulation of the bioactive components in coffee leaf and enhancing its biological activity. We also use coffee leaf extract as a substrate to prepare the coffee leaf kombucha. In bioactivity assay, we investigate the antioxidant, anti-inflammatory, anti-diabetic, anti-obesity, and intestinal barrier protective effect of the coffee leaf, combining using the cell culture method in silica model and also the animal research. So today I would like to share some of our work on using ultrasound to enhance one of the bioactive component called the gamma aminobutyric acid and enhance its bioactivity. And I will focus on the anti-diabetic effect today. So let's start with some background information on GABA. GABA is a full carbon non-proteinogenic amino acid. It actually has dual functions. In plants, actually it is a secondary metabolite that accumulates mainly under the stress. And in animals, it acts as an inhibitory neurotransmitter. GABA is most commonly used ingredient in food with function claimed in Japan. It also used as a food additive in many countries, such as Japan, US, and then Europe and China. It's been included in different foods and beverage, and also can be used to make the nutraceuticals. GABA is a functional compound in both plants and mammals. In plants, it helps maintain the carbon and nitrogen balance, regulates the internal stress, improving quality and storage performance of fruits and vegetables, and can regulate plant growth and promote the accumulation of the phenolics. In mammals, it can use to reduce the fatigue, anxiety, depression, and improve memory, sleep, and then it also has anti-inflammatory, anti-hypertension, anti-cancer, anti-diabetic effects. So this figure shows how GABA is made in plants. There are two main pathways. One is the GABA sham pathway. The other one is the polyamide degradation pathway. So the GABA actually in plant is majority synthesized by the GABA sham pathway. So there's a key enzyme involved in the biosynthesis of the GABA. One is GAD, GABAT, and DAO, PAO, and AMADH. Normally, GABA levels in plant are quite low. So to boost its accumulation in plants, researchers use different methods such as the anaerobic treatment, germination, salt treatment, microbial fermentation, and ultrasound to increase its levels in the plant foods. We use ultrasound to accelerate the accumulation of the GABA in coffee leaf. So the ultrasound actually is a non-thermal processing method that has been used to enhance the accumulation of the bioactive compounds in plants. In our study, we applied ultrasound. We optimize the different parameters of the ultrasound. For example, we change the frequency, pH, incubation time, ultrasound power to increase the GABA accumulation in the coffee leaf. And then under the optimal condition, we were able to increase the GABA level 1.6 times, and also increase the angiotensin converting enzyme inhibitory activity by 37.5%. This enzyme is related to the hypertension. Now let's take a look at how ultrasound enhanced GABA levels in coffee leaf. We found that in ultrasound treated coffee leaf, the activity of the GAD, DAO, AMADH actually get highly increased, and GABAT activity is decreased. This result suggests that the ultrasound boosts GABA accumulation by modulating the activity of the key enzymes. We also look at the metabolite profile change in these two leaves, in the leaves ultrasonication, and then we found that ultrasound actually mainly affected by the metabolism of the carbon and nitrogen compounds, such as the amino acid, carbohydrate, and pyrimidines. And the ultrasound affect many metabolic pathway, include the TCA cycle, ischemic acid pathway, glucose metabolism, amino acid metabolism. And we also use the transcriptomic analysis method to investigate how ultrasound affect the gene expression in coffee leaf. And then we found that there are 1,053 gene actually differentially expressed ultrasound and treatment. And those genes are mainly associated with the cellular process, cellular anatomical entity, and the catalytic activity. So, and then these genes are involved in the metabolic pathways altered by the ultrasound, including the GABA biosynthesis, TCA cycle, amino acid metabolism, and flavonoid biosynthesis. Author expecting that the ultrasound can enhance the accumulation of the bioactive components in coffee leaf. Then a next important next steps is to examine how this enhancement influences on their biological activities. In this presentation, I will focus on the anti-diabetic potential of the coffee leaf. Before addressing this effect, I will briefly provide some background on the diabetics. So the global, here's is a map, a data showing the number of people with diabetics in 2024 and 2050. We can see that there's is estimated to have about 588.7 million of the population adult has diabetic, and then it will be projected to raise to about 850 million in the 2050, and China, United States, India, United States, they are the top three countries have the diabetic patients. Diabetes actually can cause approximately 1.5 million deaths annually and rank as ninth leading cause of the death worldwide. And then this figure shows the total diabetes-related health expenditures for adults with diabetes in 2024. In total, the global economic burden accounts for approximately 1,015 billion USD. And then the United States, China, and Brazil are the top three countries with the highest diabetes-related healthcare cost. So as we all know, diabetes actually is a chronic metabolic disorder characterized by the hyperglycemia, and its pathogenesis actually is multifactorial. The three major aspects contribute to the development of the diabetes. First, let's take a look at the glucose absorption part. So we all know that the glucose actually in the blood glucose in our body actually mainly comes from the starch. The starch is our major primary source for the glucose. It is digested by the alpha amylase and alpha glucosidase to produce glucose in the GI tract. So therefore, if we can inhibit those two enzymes, then it will lower the glucose level in the GI tract. Therefore, it will decrease the blood glucose level. And the second one is the diabetes actually is highly associated with the insulin. So in type 1 diabetic patient, normally the insulin actually, the secretion of the insulin actually is insufficient. In that type 2 diabetes, normally patient has an insulin resistance. All those both reasons and can cause the increase of the blood glucose level. So, but then if we can use some natural health product to restore the insulin resistance in the type 2 diabetes, we can elevate the diabetic symptom. And then also like chronic hyperglycemia also can promote the formation of the advanced glycation end products. Those actually is a product produced by reacting of the sugar with protein, just like a Maillard reaction in food system. So and then those AGEs actually can contribute to a lot of complications such as the cardiovascular disease, kidney disease. So making AGEs its a precursor as inhibition is another key strategy in the diabetic management. Today, due to the time limit, I will only focus on our research related to how coffee leaves extract can inhibit starch digestion. So so let's take a look at here is showing the IC50 values of the coffee leaf extract against alpha amylase and alpha glucosidase, and we can find that both of them has can inhibit those two enzymes, but coffee leaf extract that you with the ultrasound treatment. This is treated with ultrasound. This is without ultrasound treatment. Actually, we can see that the IC value of the CLEU is lower than the non-ultrasound treated samples. So indicating that the ultrasound treatment actually can increase the inhibitory activity of both enzymes. So the kinetic analysis revealed that coffee leaf extract actually can reversibly inhibit both enzymes, and for the its effect on the alpha glucosidase actually is non-competitive, but for the alpha amylose, it's for alpha amylose actually it's competitive. So then let's take a look at the for the kinetic and thermodynamic parameters. The results indicate that they are actually they indicate that there's interaction between the coffee leaf extract and the enzyme, and it is a simultaneous and thermic reaction. So from the steady state fluorescent spectrometry analysis, it shows that coffee leaf extract can induce coffee leaf extracts actually can induce the conformational changes in the enzyme and leading to increase the fluorescent intensity, and also for thereby suppress the enzyme activity. And then for the synchronous and the 3D fluorescent spectrometry analysis demonstrate that those extracts can alter the microenvironment of the tryptophan and the tyrosine and tryptophan residues in both enzymes, and it also changed the backbone change, the polypeptide change backbone and the 3D structure of the both enzymes. For the circular dichroisome spectral analysis, further confirmed that coffee leaf extracts change the secondary structure of the both enzymes and prevent the interaction between the enzymes and the substrate, thereby decreasing the enzyme activity. So we use the molecular docking to analyze the binding interaction between the bioactive components in CLEU and both enzymes, and find out that those bioactive compounds can spontaneously bind the key amino acid residues surrounding the active site of these two enzymes. So for the then let's take a look at the how coffee leaf extract inhibit the in vitro digestion of the potato starch. We found that the CLEU can dose-dependently reduce the hydrolysis rate of the starch and increase the relative content of the resistant starch and slowly digestible starch while decrease the rapidly digestible starch.
So to summarize, we found that the ultrasound treatment can significantly increase the accumulation of the GABA in the coffee leaf, and coffee leaf extract can inhibit alpha amylase and alpha crucidase activities and decrease the starch digestion rate, suggesting a potential reduction in the glucose absorption. We also found that ultrasound treatment actually can has a stronger ultrasound treated coffee leaf extract has a stronger anti-diabetic effect compared to the untreated coffee leaf extract. So for the future perspectives, we can focus on how to increase the sensory quality of the coffee leaf tea through the processing and understand the mechanism of the accumulation of the bioactive components such as GABA phenolic compounds and other compounds that using the novel processing method. And also there are that of the in vivo study. So more animal study, even the clinical trial can be done in the future. And also like coffee leaf tea extract can be included in skincare products to make a new cosmetic or skincare product. And we can also use coffee leaf as a biomass for energy production. And those are the papers we published related to the topic about the coffee leaf tea, coffee leaves. And then thank you for your attention. This work were mainly done by one of my PhD students and one of my master students. Thank you.
Okay, thank you, Xiumin. That was really fascinating. While we wait for questions to come in, I have a couple questions that I wanted to ask. Oh, sorry, we have someone with a hand up. Andrew, did you want to ask a question?
Yes, I didn't want to cut you off there, but yeah, I guess since my mic's open now, I'll just continue. So Xiumin, thanks for an interesting talk. I've been following your work since Citrus Peels, and you've really given it life to hear how you've summarized it so elegantly with your many papers on the subject. I'm very excited to see where things are going to go in commercialization. Can you speak to the opportunities for scale up and what there may be in terms of going to the ton scale if you're going to be processing coffee leaf, and what maybe you're currently using right now at the lab scale?
We actually doing in the lab scale, but then I believe you know the Wise Monkey, right? Wise Tea, the company. Yeah. So they have a plant in Nicaragua. Actually, it has a quite big facility in the Nicaragua. The plant they processing their coffee leaf there, and also I know in China also has a company right now. They are planning to make a coffee leaf tea and then to sell it. Yeah,
okay,
actually,
but the infrastructure for the sonication units, like I'm familiar with the
sonication.
small scale.
Oh, you're talking about sonication. So
yeah, ultrasound.
Actually, the sonication, we in our like university, we have the belt sonication instrument. So like you know that there's some company use the ultrasound to clean the vegetables, right? So there's they actually has the pilot big lab scale and that's on the pilot plant or industry level of the ultrasound instrument can be used especially in a company like who doing the washing. Actually, so what you need to do is only adjust the parameters. So make it clean. It can clean the leaf as well as it can boost the bioactive components in the leaf of vegetables. Actually, in our team, there are other professor and my student, we're working on those part as well. Like we increase the phenolic compound composition, and then also, and some my colleagues are doing the green onion washing, and the ready-to-eat vegetable washing using ultrasound, and then they test for after the processing, they find out actually the biotic component actually also get increased.
Okay, well, it's good to know you can repurpose that equipment. Thank you.
Yeah.
That's amazing.
Yeah.
So we do have one question in the Q&A, but we'll have to keep it very brief because we're a little over time. The question is, could you give an indication of the amount of coffee leaves that are currently being wasted globally?
The amount of it. I don't, I believe I read somewhere in the paper, but I forgot. There's some review paper about reading, but then we can think about it that normally when in a plant, in a coffee plantation, like people normally like we need to trim the coffee branch like the regularly in order to increase the bean production. So it normally like 10 to 30%, and the branch will be trimmed, and then those the branch with the coffee leaves, of course, like normally they just discard it in in landfill. So that actually is quite a big waste for the coffee leaves.
Sure, sounds like it. Okay, thank you so much, Xiumin Chen.
You.
Next, we have a lightning talk from Dr. Staniotis. So Emily Staniotis, over the past 15 years, she has contributed to innovative food systems initiatives across the globe in North America, South America, Europe, Asia, and Africa. Her doctoral research leveraged multi-scale food systems data to build an informatics framework for substantiating milk bioactive claims, and was supported by IC Foods, a nonprofit building food system cyber infrastructure. Alongside her PhD, she designed and evaluated commercialization strategies, worked on industry-leading databases, and developed impactful programs and partnerships in agri-food tech. And she now serves as the founding director of IC Foods Canada's office. Please welcome Dr. Emily Staniotis.
Thank you so much, Alexandra. I appreciate the introduction. Get my slides here. Okay, good.
All good to go.
All right, thank you. So yeah, such interesting talks. My talk is going to be a little bit higher level, a little different. I've really dove into the informatics data management space. My research was originally more in food biochemistry, but I worked a lot on food sustainability databases. And so I became interested in kind of the role of informatics and data management systems in accelerating food sustainability. That work led me to IC Foods. As Alexandra said, I am the director of the Canada office for IC Foods. So it is a nonprofit research institute building information systems and databases, knowledge bases, and all with a lens toward machine learning and AI to accelerate food systems research. And that can be anything from upcycled foods to regenerative agriculture to nutrition policy and stuff like that. So I'm really passionate about developing this accelerating this field of food informatics, and also bringing a sustainability lens to it. I also, just want to disclose that I also have a small business on the side called the Job Feed, and I'm just going to talk about it a little bit at the end, as it kind of is the work for it. I'm talking about my research first with IC Foods, and then the workforce development angle is how I'm leveraging the same types of tools in that initiative. So people just like, first, food informatics is not a super common term, but like bioinformatics, right, is pretty common in the research space. Geographic information systems, health informatics is used widely in terms of like electronic health records in hospitals. At IC Foods, we're accelerating just like the development of food informatics as an independent discipline and educational resources around it. So we think food waste and the circular economy of food is a really important application of food informatics because if you're kind of thinking what's the difference between informatics and data science or AI, it's all related. But one of the things that we are experts in the informatics world is something called ontologies, which is down here. But really, it's like about creating standards, data standards and data frameworks that clearly define and measure and integrate data. So this is really important for some of like the downstream, data science, machine learning, AI applications, because if you can't define, what do you mean when you say upcycling, what does that mean, right? You have the Upcycled Food Association, which, created the definition, and, that definition would absolutely be used in our data systems and data information systems. But how do we integrate those definitions with definitions of, other definitions in the food waste domain, and then create a database and like a logic system so that machine learning and AI can reason over it. So this is what I'm saying, this is how I'm terming sustainable food informatics, is just like food informatics is, applied to developing more sustainable food systems with, food waste recovery and upcycling being a huge part of it. So, the argument is that if we can't scale upcycling or these solutions to food waste more broadly, if we have a lack of semantic clarity. So like semantic as in, are we on the same page with the definitions? It creates barriers to policy, reporting, investment, and innovation. So this is a little bit of recent research. This was like recently, like a month ago, we just published it's more like a review paper, but really kind of evaluating the state of food waste ontologies. Like we found, be more, but we found in our review about 8 different food waste ontologies. But a lot of times people make ontologies, they make these data frameworks, these data standards, and then they aren't actually used. They're either because they're not aligned with formal ontology standards, which they're not accessible easily to the public. They're too complex for researchers to understand. So those are some of the things that we try to do is, make them accessible, aligned with standards so that they can be more easily usable by different stakeholders in the sustainable food waste upcycling spaces. So when I say there's no standardized food waste ontology, there are several papers that try to develop different types of food waste ontologies, but sort of in order to build one that's usually how it starts when you're building an ontology. Like people try to build different pieces of it, but in order to build one that's really widely used in the industry, we need to involve a lot of stakeholders and kind of make sure that it's interoperable. So weak interoperability is one of the gaps. So that means like you have one database about about upcycled ingredients, and then you have another database about greenhouse gases of food waste emissions or something, and you want to link them. And there's, this is one of the values of the ontology, if you do it right, is it can help you link these databases. But yeah, in our review paper, we found good thing for upcycling is that several of the ontologies did cover valorization, like food waste valorization. However, it's interesting, it's just interesting like that ontologies, in ontologies, like the words matter, right? So, not a lot of, I didn't see any of them actually that use the word upcycling. So, what is the difference between valorization and upcycling? How do we define that? as a food waste upcycled food community. There's also like a lack of verification and prevention terminologies in these ontologies, as well as in the critical gaps there, missing data around quantity, timing, destination, environmental impacts, and causes. So these ontologies are meant to capture as much information as possible, be flexible. Oops, I didn't go forward. But yeah, in general, the path forward is to build these ontologies that are open, interoperable, so they can connect with different databases together. I like the idea of incorporating upcycling as in addition to just valorization as a term. We're also working on a food claims ontology, so kind of integrating different certifications like the Upcycled Food Association, or the Upcycled Food Certification is of interest. And as I said, stakeholder engagement is really important, as well as, we're exploring different large language model methods in addition, because one of the barriers to ontology development in the past is that it's very time consuming. Also, just as like a reference point, if you are not familiar at all with ontologies or bioinformatics, the gene ontology was an ontology that was very instrumental in helping map the human genome. So that's like an example of where it's been really useful. And so that was the paper, was just like gaps. And then I went to a conference couple weeks ago in Spain, focused on information systems, and there's this food waste, or there's a food specific workshop there, and it was really interesting. There were like 3 or 4 people interested in food waste ontologies, and there was an interest. I just think the timing is really interesting, that there's a consensus. There was kind of a consensus coming out of that we need to develop a more robust food waste ontology. So I haven't done a lot with that yet, but just so you kind of understand the idea of that's our next step, and how do you go about making a robust food waste ontology. I mean, first I want to look at the research that, I've looked at some of the research that's already been done, but usually you just start by creating a structured list of core terms like waste stream, byproduct, surplus, upcycled ingredient. And, this is in the early stages, this is where you want to get consensus from different stakeholders. And then, like I said, you would use definitions from FAO, USDA, Upcycled Food Association. You don't create your own, you want to use robust definitions. And then food on is the food ontology. Matthew Lang, who is a CEO of IC Foods and co-authored that paper from the last slide, was also involved in the development of food on, which is the first food ontology. There's also industry ontologies, and we had a doctoral fellow at IC Foods work on some sustainability ontology efforts as well. So those are some ontologies that we want to align with this food waste ontology that we're developing. And just so you kind of understand, like, this is the, without getting too technical, like the idea of defining core classes and object properties in ontologies are basically just relations. So for example, if you look at what I have highlighted, if you wanted to, when we want to define waste stream as a core class for sure, and certification scheme as a core class. And if we wanted to link waste stream to certification stream, we could use the object property eligible for certification. And so it's like it's a data framework. I said it's a data framework, but it's also like it has logic embedded in it. So that's one of the values compared to just like pure AI or something. It's really transparent, and you know exactly what is happening in the back of the information system. And so this is just me briefly, I'm sorry, I don't know why it's moving. This is just me briefly saying that these are some educational projects that we are working on around food informatics. So we're working on a textbook to kind of establish it as an independent field called agri-food informatics. We have some food waste and people involved in the Upcycled Food Association who are part of the chapter titled Informatics for the Circular Economy of Food. That book should be published probably not till next summer-ish. But yeah, we're editing it and rounding up authors for different applications. And we have a circular economy chapter. So I just wanted to highlight that. And we also got some initial funding at IC Foods from an AI institute to develop like a micro-credential program in food informatics. So, teach food professionals, food researchers, food domain experts, some of these informatics skills. And then this is a project that was like research and education. And this is, my own project where I'm leveraging some of these food informatics tools to categorize and tag sustainable food job and career data. And so I just, it's a demonstration of the versatility of these tools, and also just transparently, short plug for what I'm doing. I think it's really, very needed. There's sort of like to bring together these different domains in sustainable food systems and, create like a job board and a career platform where people who have these like specific interests can look for jobs and where employers can post jobs. And also, dedicated to building it out so that there's more professional development options, and that's my next step. So just, sustainable food informatics is a fairly new term, but I think it's really important in terms of advancing upcycled food, the circular economy of food. There's a lot of, and one of the things that I think is, the major first step there is really getting on the same page about an ontology and food waste and recovery. And then, if you're interested in, if you're a food sustainability professional and you want to learn more about food informatics, that's also something that we can help you with. So yeah, I think if you're interested, just let me know. You can reach out to me at my IC Foods email if it's more around education or research, and the job feed if it's more around the career development and workforce platform. Thank you.
Emily, thank you so much. I will give a plug. I send people to the job feed frequently and often, so it's a great resource, and so fun to see kind of the look under the hood of how it all came to be. So as we wrap up our time here, I want to welcome any questions for Emily in the Q&A feature. I know I'm really curious, Emily, one of the themes of today and yesterday, how do you approach and navigate translation differences in languages as you think about building these models? We had a great
oh yeah, that's a really interesting question. Was a theme of yesterday?
Yeah, we're talking about kind of not translating into Polish, translating into Dane, just thinking about all these different cultural nuances around the words we use.
Yeah, and in like a specific database or just in general?
Just in use, thinking about upcycling, how it does or does not translate.
Yeah, that's a really interesting question. Yeah, there's been several approaches that people take in the ontology world. I think there's, it's not necessarily a consensus, especially now with like large language models and AI. I think people are exploring that as a way to translate things faster, although, definitely needs to be checked for accuracy. I think there's this I'm trying to remember the name of it. So Lingual is an international framework for food description that's automated, and they are kind of leading the charge in translating. So we usually try to integrate with their terminology. But yeah, I think the AI approaches are also becoming more common. But yeah, it's definitely something that's really important to us. And yeah, Matthew, our CEO and founder of IC Foods, he's done a lot of work around just like making sure, because I think sometimes it's not done well, like making sure that when we're building these databases, we understand the cultures of different foods, because it's just, food is not, right? Food is such a hard thing because it's not, if you like reduce it to just data, I mean, I'm also like a biochemist, right? I think you don't want to reduce it to food, just to biochemistry or data, right? There's such a cultural aspect to it. And so we can also capture cultural nuances in the ontology. So that's the value of like using an ontology rather than like a more simple, like a simpler data schema, because it doesn't allow for that flexibility and nuance in, tagging things about different cultures, and potentially translating as well.
Okay. Oh, well, thank you for grounding us in the humanity that is food as we wrap up a great couple days. I think in the spirit of time, I know we've gone over and folks have been with us for such a great long day. So thank you, Emily, again.
Yeah, thank you so much. Appreciate the question. That you know of the geography.
As we wrap up today, just want to extend a huge thank you to everyone that participated in today and yesterday and making all this possible. Again, a big thank you to Dr. Laura Ramden, her brainchild, and all she's done to help make everything that we've seen here on screen in the past 7+ hours. Just another shout out, kind of our next moment of convening Food Ingredients Europe featuring UFA this December in Paris. So do check out that link and the Lunch and Learn hosted by 2 of our emeritus board members. And then definitely keep in touch, whether you're already a part of this community or have interest in joining us. We have a really wide range of $50 student memberships, $100 individual memberships, organizational and business memberships. So I'd love to keep involved and keep you in conversation. This community kicked off in June, this Upcycled Food Month, and the intention is to gather again as our next symposium in June of 2026. So we have a lot of time to plan and design and think about what that convening can look like virtually, and then what are the interest points of collaborating in the meantime. So really welcome your ideas, your participation, and as you synthesize and simmer on everything you've heard today and yesterday or are listening to in the recordings, let's keep this conversation and collaborations active and alive. And I know you've added so much to my brain database from these hours, and look forward to incorporating all that we've learned here and continuing to celebrate and further the innovation of this movement and where the Upcycled movement is going globally. So thank you for your role in that, past, present, and future. Do keep in touch. Stay well.